Alright, everybody, here we are, and finally, after wait of a long time, finally here we are, and we will just simply go through the Kubernetes section. Most probably, all the things that I needed to learn that are really important for the deployment purposes and all. At least the basic stuff has already been covered. And as for the remaining things, we are gonna be covering them too. But it's better to just simply go through all the things that I've learned and just simply do it in action, because just theory is not gonna be enough for us. So I'm just gonna be working on this particular thing. Again, few things are already running, so I will be just simply like stopping them. And this is how I'm just simply gonna be going ahead from here. So first of all, I actually forgot to stop. I was supposed to be stopping them even before starting the live, but it's okay as it has started, so that's not really a big problem. I'm just simply gonna be going ahead with this. I hope I'm audible right now. Okay, yeah, and just ignore the background noise that is just coming because yeah, some work is going on, so can't really do anything with that. Talking about the Kubernetes, so we will be starting the things from scratch. We are gonna be even going with the theory part, and this is how we are gonna be just simply covering the things one by one. As for right now, a few things are already running. I will explain each and everything, but before that, let me stop some of the things here. So, okay, get nodes. Few nodes are already running. Okay, delete. How am I supposed to be deleting the cluster? I think if I want to delete the cluster, I will have to run EKS ctl delete. If I actually want to delete it from, okay, EKS delete cluster. What is the command for that? So let me go to the AWS EKS, and over here I have all the commands mentioned. Delete cluster and specify the cluster name. Okay, so EKS delete cluster, the cluster name is gonna be my EKS and cluster, just like this. It should be just deleted now. I'm gonna be talking about each and everything, and first of all I'm gonna be talking about this AWS stuff, exactly how it's gonna be going on. Having said that, I do have some doubts as well, so I'm gonna be talking about those doubts. I mean, asking the things from the AI related to that particular topic, and that is it. This is how it's gonna be going on. By the way, it will take some time to just simply stop it. So usually it should take around 10 minutes or something, and within 10 minutes, the Kubernetes cluster that I have here, that should be stopped. Again, how I created the Kubernetes cluster, how are the things working on here, don't worry about anything. We will be just simply going through each and everything. As for these nodes that are related to EKS cluster and all these gonna be stopped automatically, so we don't really need to worry about anything. Later we'll see if there's something extra, and after that we'll continue from here on. As for right now, load balancers, they should automatically be stopped. So if I go to the EC2, let me at least remove the load balancers from here. So if I go here and select this load balancer, let me click on the action and delete load balancer. I may not be able to tell everything from scratch, but whatever I'll do here on the screen, I will be just explaining each and everything. Okay, so this is how the things are gonna be going on. Node app target group, I don't think I need this here, so let me delete this as well. Ultimately I'll have to delete, yeah, few things that are extra here, so I'm just simply deleting them first of all, keeping that thing in my mind. And once that's done, even this R2 scaling group EKS my nodes, it needs to be deleted. The thing is that there are many things that are already created and they are not needed, so let me just remove all the things. And if you know them, so you must get the idea exactly what I'm doing. If you don't know, just simply ignore, don't worry. AMIs, I don't have any instances. These two are going to be stopped automatically. Alrighty, so what we are gonna be doing here, first of all we will be starting from scratch. First of all we are gonna be talking about Kubernetes and all, and this way we'll start from the beginning, go till the end. That simply means the deployment part. So first of all we discussed about Kubernetes, exactly what is Kubernetes. We have clusters in Kubernetes. There are some jargons that you have to know about. So there's something called node, worker, control plane. Okay, and inside them there are many things. So if I just simply open, I'm not going to be talking about these things much because of course I have already discussed them, but we'll be having a glance at them. So this is how it's going to be going on. Even I created lots of diagrams here explaining these things. So all these things have already been covered. Again, this is just the learning sharing. So we have a Kubernetes cluster, we have control plane, we have nodes. Inside the node we have kubelet, kproxy. What they do, we have even talked about this. We have even container runtime that is responsible for running the container. We have kubelet that are responsible for running the pods and again running the containers with them. And we have kproxy that is mainly used for networking stuff and all. And at the end, even inside the control plane, we have API server that is responsible for getting the requests. Then we have control manager, that is responsible for managing this stuff. We have cloud control manager that is responsible for connecting to cloud provider and all. And then we have etc, that is nothing but the storage. And we have schedulers are used to assign the right port to the right node. So this is how it just simply goes on. It will check whether there is a pod or not, there is extra pod or not, and once it gets a pod, empty pod, it will just assign that port to a particular suitable node, as simple as that. So this is how the things go on. Ultimately, this is the overall diagram of ECS service provided by AWS itself. The full form is Elastic Container Service. The thing is that whether you talk about ECS or you talk about Kubernetes, ultimately both of them do the same thing. ECS does the same thing. ECS manages your containers, updates them, creates new containers, deletes new containers, auto scale them, auto downscale them. So this all is done by ECS. The same job is done by Kubernetes. The only difference is that Kubernetes is not platform dependent. That simply means if you know Kubernetes, you can use it on AWS, you can use it on DigitalOcean, you can use it on Azure, any cloud provider. And ECS is completely dependent on AWS. That simply means if you know AWS, then you are dependent on you will have to use ECS. Apart from this particular thing, you get more configuration in Kubernetes, right? So this is how we are this is how the things have been going on so far. We have already discussed what is node, what is master and all, so not gonna be talking about that much here. Okay, let's delete this and delete this as well. Coming back to my notes, so over here we have quite a lot of things. We are going to be starting with clusters. There are just simply some links here, so don't worry about that. The important thing starts actually from here. First of all, we will create proper clusters. We have already done it, so we will not do it now. Rather, we will just directly be, or should we do it? Let's try to do it one more time. Why not? So let's see. By the way, it's gonna be okay. The cluster has been deleted. So if I say k, what command should I run? K get, K stands for kubelet. So kubectl. So kubectl get clusters. There are no clusters. Kubectl not get clusters, get nodes. There are no nodes, get pods. There are no pods. So ultimately everything is stopped. As simple as that. And now what we have to do, one more thing here. I'm not on my local device. So in order to be on my local device, I have to run kind create, right? So this way I will be on my local device here. So what am I gonna be doing here? First of all, I will be creating the clusters and all on my local device. Once all these things are done, then I will be just simply going ahead. So first of all, we are gonna be first setting the alias. Alias is already set. K is gonna be referring to the kubectl. So this is already done. We are gonna be creating a cluster. There are two ways you can either create the cluster directly. So like using kind create cluster. The name of the cluster is gonna be local, just like this, and the cluster is gonna be created. By the way, it is just simply saying that permission is denied. That simply means just a minute. Give me a moment. Alrighty, I hope it's clear. So I was just simply saying that the container is running right now. As the container is running, if I just simply say docker process status, so these are the process statuses that are running. So let me just simply stop all these things. And even if I say kind get clusters, so I'm gonna be getting the cluster local. So let me just simply delete this cluster as well. So kind delete cluster, and the cluster is local that I will be deleting from here. Having said that, there is a spelling wrong. Cluster, so it's gonna be deleted. Once it is deleted, then that's it. We don't really need to worry about it. So yeah, K get pods. K stands for kubectl. We don't really have any pods. K get nodes. We don't really have anything as such. Let's simply clear the terminal and let's simply get started with the clusters. If I run docker process status, we don't have any process status running. What is the next thing? Kind create cluster, and the cluster name is gonna be local. So ultimately a cluster is going to be created. But the thing is that in this particular cluster, your control plane and workers, they are kind of combined. There's only one control plane that you get, and that is not that is actually both. So we have to specify that we want our clusters and worker nodes separately. So we will have to even do that manually. But as for right now, if I say kind get clusters, so here this is the local cluster that I have. And apart from this particular thing, what I think once the cluster is created, I should be able to run kubectl get nodes. So here I'm getting only one node, and that is the local control plane. That simply means I don't have workers separately. So kind of I can say it is a combination of both. The question is, how am I gonna be getting the workers? Okay, so if I want to get the workers, first of all I will have to delete it. So kind delete. Again, kind is mainly used for creating a cluster, and you just create the cluster in the development section. In production, cluster is created by any cloud provider. So if you are using AWS, so AWS will be responsible for creating the cluster. So though AWS gives you commands to just simply run to create the cluster, but ultimately the whole job will be handled by AWS. Similarly, if you are using DigitalOcean, so DigitalOcean will be responsible for creating the cluster, a Kubernetes cluster. That simply means you do not need to use kind over there. Kind is mainly for just the development mode, in development environment, and kind is the full form of kind is Kubernetes in Docker. I hope it does make sense. So delete kind, I wanna delete cluster, so cluster, the name is gonna be local. So this is how I'm gonna be going ahead. Okay, so it's gonna be deleted. I hope I have turned the chats off and all, because of course I'm not gonna be, yeah, it's already off. It's not gonna be possible for me to just simply answer them. Okay, going ahead from here, this much of course we have done, pretty simple stuff. Let's continue from here. So we have already gone with this first step. Okay, so ultimately what I'm saying, this is the full form of it. Let's not worry about this. And apart from this particular thing, we have kind of create cluster. This way we just simply create the cluster. You can even check it in the process status. You can get the list of all the clusters you have created. Cluster info, you can know more about the cluster, exactly where it is running and all. Kind delete cluster, this is how you can delete them, and this is how you can just simply set some aliases. So this is nothing but just for setting the alias. So this much we have done. Then we have something called clusters.ml. This is nothing but a ML configuration file. It just simply configures your cluster and all, how many control plane you want, how many workers you want, and just like this, it just simply goes on. Okay, so we are gonna be even talking about this one by one first, but before doing anything else, keep in mind that you can directly create the cluster using the command line, and you can even create a configuration file like ML file. That configuration file will be, if you apply that, if you run that, so that will be responsible for creating the clusters. So these are the two ways. And the second way, where you are actually just writing all the configuration, exactly what you need and all, and that is actually saved in a file. That is a better way, because if you are writing the commands, you will have to rewrite those commands over and over. By the way, talking about this, so we have talked about Kubernetes, quite basic stuff. Okay, and after that we have talked about, we have even gone to the backend stuff, how we even deployed the backend directly, like in EC2 machine. We have even deployed front ends like Next.js that can also be deployed in EC2 machine, and even we have done that. Not only that, we have even deployed React in a CDN, how it's done and all. We have done it in past, if you and no doubt we will be doing it in future as well. So these things are already done. Going ahead from here, there are few jargons that you need to know. There's something called nodes. There is something called master node. Inside the master node, API server, etcd, kube scheduler, kube controller manager, and controller manager. So cloud controller manager. These are some of the jargons that you need to know. These are some of the kind of features, you must say, the things that you need to know if you are actually learning about Kubernetes. So just know about them. I will not be talking about them much, because in previous slides I've already talked about them. Then inside worker nodes, we have something called a kubelet, kube proxy, container runtime and all. Container runtime is mainly responsible for running the container. Then we have a cluster, images, containers, pods. What is a pod? Pod is nothing but a kind of a machine that is responsible for running the containers. Okay. So ultimately what happens, that you create a pod, that pod itself is responsible for running the container, and pod is overall kind of a environment that runs the containers and all. This is how it just simply goes on. Alrighty, so this much we have already gone with, and then we are gonna be creating the clusters locally first of all. Then we will create the cluster on AWS. Why not on DigitalOcean? Because I don't have the subscription of DigitalOcean. As soon as hopefully within a week I will be getting that too. So then we will be exploring DigitalOcean as well. But as for right now, I just have the access of AWS. So I'm gonna be getting everything done on AWS. So this is how it's gonna be going on. Using kind of by the way, the cluster is gonna be created using kind. So we have to just simply say kind create cluster, and it is going to be created. We can even delete the clusters. We have even this clusters.ml file. So using this clusters.ml file, we can just simply create the clusters and all. So let me do that. Let me do everything manually as well, because let me delete this. This is just gonna be for the learning purpose. So I'm gonna be going to the learning, and let me create one more, or even better, this Kubernetes self that I had. Let me create a self here, or Kubernetes self. The folder is created, and inside this I will be getting everything done. Okay, as simple as that. This is how it's gonna be going on. And first of all, I will be getting everything done locally, and after that I will be even creating the cluster, even deploying the things on the AWS. And not only that, we will be deploying it, we will be setting the domain name, and at the end of the day we will be adding the certificates, so that instead of using HTTP, we are actually able to use HTTPS. Okay, so all these things are gonna be happening, but of course we can't really do everything just at once. Apart from this particular thing, I'm not gonna be creating an image from the scratch, though we can do that, but we will be using Nginx, MongoDB, and some other images. So you already know Nginx, we can get the image from the Docker Hub. So these are the images that we are gonna be using just for the demo purpose. Once we have gone through all this process, soon we are gonna be building a project that and we will build the image and all, and then we will be even deploying that. So this is how things are gonna be going on, and I hope it does make sense. By the way, coming back to this one, first of all, I actually need to create a cluster.ml. So vi cluster.ml here. This is the file that I'm creating. Why am I creating it? So that I can configure it. By the way, I can directly create the cluster. So I can just simply say kind create cluster.ml cluster, and I can specify that the name of the cluster is gonna be this. So this way cluster is gonna be created, but I need to make sure that there are workers, and for that thing I will have to configure a file. So vi cluster.ml. It's gonna be pretty simple. I will not be taking a lot of time over here. Let's simply put the input mode. I will be copying and pasting the code that's already in my notes actually. So this is the code that I have to copy from here, and this is nothing but my notes. So let's simply paste it here. This is the code that we have over here. I hope it does make sense. And what it does, it is just simply saying that kind is gonna be cluster. API version is this. You can even get it from anywhere. Node. So how many nodes should be there? There should be 3 nodes. So first one is gonna be control plane. The remaining 2 are gonna be workers. Let me save it here. It's been saved, and once it is saved, let me just simply cat cluster.ml. So we have this information, like the configuration here. It's pretty simple. Kind is gonna be cluster because we want to create a cluster, and etc. Having said that, we've already talked about all these things in detail. If I just simply apply it, ultimately if I try to create a cluster, so kind create a cluster. What is the configuration here? The config is cluster.ml, and if I just simply run this, so a cluster file is going to be created. The name doesn't really matter. You can just name it anything. I've named it clusters over here. So in my notes, I've named it cluster. I could have named it cluster as well. So that's fine. You can go with any name as such. That doesn't really matter. But once the cluster is created, then you should be seeing the result. So let's wait for a while, and all these things are gonna be done in production as well. So once the cluster is created, kind get clusters. I should be getting all the clusters. Right now I have a cluster named kind. The main problem is that the cluster's name is kind here, because I did not really specify any name at the top. So what will I be doing here? First of all, I will actually delete this cluster right now and create new ones, because that cluster should have some name, right? This kind name I got by default. So kind delete cluster, and the name of the cluster is kind right now. So let's simply enter kind over here, and this will automatically be deleted. Why I deleted this? Again, inside this I had 3 nodes: kind control plane, kind worker 2, kind worker. But again, we don't need this. We want to specify the name from our on-site. The worker is gonna be the cluster is gonna be the local one. So this way I have specified the name for that particular cluster. Let's wait for a while, and it's gonna be created. Even if possible, it should be local cluster or something. So can I stop it just right here? Kind get a cluster. So okay, I have already that. So delete cluster name. Just trying to give it a proper name, nothing else. So local. This is how it's gonna be. Am I facing this? Okay, the spelling is wrong here. As for the duration of this live, it will just keep going on. So unless I am done with the things, I will not stop. As simple as that. So there are 2 things. First of all, going through all the stuff related to the Kubernetes, and after that going through all the stuff related to the Google Meet clone that I was working on. So ultimately we are gonna be going with both. By the way, let's simply create the cluster using this cluster ml file that I have over here. Again, by the way, what is the problem? Kind is not allowed. Kind is not allowed. Property kind cut. API version is not allowed. Ultimately, if its name is clusters or maybe CS, it doesn't throw any error. But if its name is cluster, exactly, but cluster, still it doesn't throw any error. But if I make it cluster only, just cluster alone, then it just simply throws me the error. So let me make it clusters only right now. It doesn't really matter what you name it. Even it doesn't, it just it is unable to kind of configure this, or it is unable to, maybe because the cluster is the key name the name that is actually used in Kubernetes and all, and because of that thing it was just simply giving me the errors and all. So I named it cluster. Even in my notes I had the clusters name by default. So okay, you can name it anything, but I think cluster is actually used in the code and all, and because of that thing cluster is actually used from the Kubernetes side, and because of that thing it was giving me the error. Not sure, but could be. But okay, what do we have to do? Kind of create cluster. Okay, cluster, I want to create a cluster. The name of by the way, what is the configuration for creating the cluster? Configuration is for creating a cluster is clusters.ml. What should be the name? Name should be local cluster. So this is the cluster that I'm gonna be creating. Let's simply run this, and ultimately cluster is gonna be created. Once the cluster is created, then of course we can just simply check the nodes inside. We can just simply check the nodes. Apart from this particular thing, there is something called Minikube. We can even know more about that. Having said that, as for Minikube, I'm not gonna be exploring it right now, but definitely I would love to know more about this in future. So I have just a link of this Minikube here, so gonna be pasting here at the top /web. Okay, later by the way, let me keep it inside links only, so inside this it's gonna be going on. Okay, then so what I'm gonna be doing later in the future, I will just simply be knowing about Minikube as well. As for right now, let's simply skip this. Going ahead from here, we have created a cluster and all. The next thing that we are going to be going on, that is the Kubernetes API, and of course we have already gone with this. The thing is that whenever you run any command on your terminal, so an HTTP request goes to the Kubernetes, and with your proper credentials, that okay, you are an authenticated user, and this way you are actually able to create a new cluster. You are able to create pods, nodes, and all these things. And if you actually want to check, you can even check that thing out, exactly what kind of request goes. Just a second. And apart from this particular thing, I have started a cluster over here. Let me see whether I have the cluster. So kind get clusters. So this is a local cluster that I have created. Apart from this particular thing, kind not even kind if I run docker process status. So I will definitely be getting this local cluster control plane I have, local cluster worker 2 I have, local cluster worker I have. So ultimately I do have the clusters over here. Okay, so apart from this particular thing, if I wanna get my nodes, so kubectl get nodes, I'm gonna be getting the nodes from here. So ultimately this is simply telling me that I have local cluster control plane, I have worker 1, worker 2. So this is how the things go on. Again, K stands for kubectl over here, so I have just simply set an alias K kubectl, and because of this alias, if I run K, so that stands for kubectl only, so I can just simply say K get pods, and I'm gonna be getting the pods. Oh no, I think kubectl, the spelling is wrong, sorry. Alias K is gonna be equals to kubectl, just like this. Now if I run K, I'm gonna be getting, that is just the same as running a kubectl here. So K get nodes, I'm gonna be getting all the nodes. K get pods, I'm gonna be getting all the pods. I don't have pods. K get replica sets, I don't have any replica sets. K get deployment, I don't have any deployment. K get services, I don't have. I do have a service, that is Kubernetes cluster IP, that is by default. I can even say K get SVC, so I'm gonna be getting the service. And apart from this particular thing, K get LB load balancer. Here, I think Oh yeah, you can't really get load balancers directly. So these are the commands that we need to know exactly. And even at the end of the day, we are gonna be going through each and everything. Coming back to this one, if I say docker process status, so this is the process that is running. If I just simply hover over this, or if I go to this particular port, so what will happen here? So client HTTP request got sent to HTTPS, and if I just simply make it HTTPS here, just like this, so it is saying that you cannot go there, so I'm just gonna be going there forcefully, and it is saying that forbidden. Why it is just simply saying me that forbidden, can't get path ultimately. When I sent a request from my terminal, I was authenticated user because inside kind, so if I show you the file, so cd and dot kind, here I have not this one actually, cd kind, I should be able to go inside this. What is the problem? No such file. Cd this lsa, I should have kind here. Don't I have the kind? I have .aws. We will be talking about this AWS as well. Not really a big problem, but I should definitely have kind. Oh, it's not kind actually, cube. So cd dot cube. Inside dot cube I have config. So as you created your cluster locally, so what happened inside config, your authentication related stuff, your authentication related kind of files got saved, code got saved inside this. So there are tokens inside this. They are gonna be making sure that you are an authenticated user, and whenever you are making any request from terminal to the Kubernetes, at that time all those headers and all the tokens and all, they are just simply sent along, and this way you are considered as an authenticated user. But when you directly make a request from a browser, you just simply send an HTTP request. You don't really send any headers and all, not even a token, nothing at all ultimately. By the way, I cannot really show exactly what all we get here inside this, but ultimately you do get lots of things, right? So this way, if you send a request from the terminal, you get authenticated, and that is why you just simply get the response as well. So these are the things that we've gone with. And apart from this particular thing, by the way, if I talk about what all we get, so inside this config file we get clusters, and inside the clusters we have some certificates, and we have some context and yeah, something like that. So kind of it contains some certificates that make sure that I'm an authenticated user. Okay, I hope it does make sense. Going forward from here, so we have even started using kubectl, and if you're actually worried about like what is this kubectl and all, so kubectl is nothing but a command line. So first of all, I use kind was used for creating the cluster, and once we have created the cluster, then if you are gonna interact with the cluster, at that time you are gonna be using kubectl. Okay, so if you wanna get a pod, so just simply say k get pods. Again, k stands for kubectl. If you wanna get the nodes, so k get nodes. So this way you are just simply getting a node. There is a main master node that is called control plane, and there are two worker nodes here. So I hope it's clear. Going ahead from here, if you don't have kubectl, you can definitely install this, and kubectl get nodes, kubectl get pods. This way you can just simply get that. Not only that, once you are getting the nodes, you can even get the nodes in the, you can increase the verbose number, like verbose gonna be 8, so you are gonna be getting more information and all, and this is how it simply goes on. Coming back to my notes, I have even just mentioned everything over here. So first of all, we discussed about all these things, then we discussed about this configuration. Simple, easy peasy. This is a configuration to create the cluster. It is not really convenient to just simply keep using the command line like this. If you, and the thing is that you cannot even specify your nodes here, so it's better to just simply create an ML file with the proper configuration and simply create the cluster using that particular configuration, and this is how things go on. Apart from this particular thing, we learned about kind create cluster config clusters.ml. This is where you can just simply give it the name. So name, that's gonna be nothing but the cluster name, just like this. Clusters.ml is the file name, configuration, and then if you wanna get the nodes, run this, pods, run this. If you wanna get the pods in the watch mode, that simply means that mode will not, you will not get out of that particular mode. I will even show that. So the thing is that by default, if you get k get pods, so you just simply get out of that particular environment, right? So but if you say k get pods in the watch mode, so you will be stuck there. That simply means this particular environment, the watch mode, will never get over. That simply means as soon as you get a new pod, that new pod will be shown here because you ran this command, you are watching that continuously. So you will never exit from the watch mode until unless you actually click Control C and all. So this is how it just simply goes on. We have kubectl logs in Nginx. Again, you can just simply get the logs of any pod that you are running. Just a minute, give me a second. Alrighty, I hope it's clear. The thing is that lots of people are making a lot of noise around me, and I just wanted to say something, and then I stopped. Logs from that, and you can even follow it in the sense as the logs keep changing, as you keep as that particular pod runs, so you will be getting lots of requests in that, or you will be at least getting the logs of that, so you will be following all the logs. So kubectl logs Nginx is used for getting the logs. It is just for the follow purpose, and then this is the verbose number that you have. I hope all these things do make sense, and this is how everything gets settled, gets completed, gets covered related to clusters. Right now it's time to create a cluster, it's time to create a pod, and there are many ways actually. First of all, you can just run a simple naked command, and that will be responsible for creating the cluster. Ultimately that will create the cluster, but the another thing is that you can actually create a proper configuration file, and that configuration file will be responsible for creating the cluster. So let's simply first of all run this command, and let's simply create a cluster here, and let's simply create a pod here, and once we have created the pod like this, then we are gonna be even creating the pod using the manifest.ml. Again, the name can be anything, doesn't really matter, but I hope you got the point. Coming back to this one, ls, let's simply clear it. So it has been cleared. If I talk about k get nodes, so I have these many nodes, but if I say k get pods, k stands for kubectl. I don't really have k refers to kubectl, not even stands for. I don't really have any pod over here. Interesting. So what can I do here now? I can create a new pod, and if I wanna create a new pod, so k, that simply means kubectl create. Again, don't run create, k run, that simply means kubectl run. What should be the name of your pod? So the name of my pod should be, suppose what, Nginx pod. I'm gonna be running Nginx. Why am I running Nginx? Because I don't really have any image, and right now as Nginx is already created, MongoDB is already created, this image we can easily get and pull, so it's better to just simply use them. Later I will create my own images. So k run, and what am I gonna be running? By the way, what should be the name? So the name should be Nginx pod, just like this. So this is the pod name that we have here, and apart from this particular thing, what should be the image that we want to run? The image should be Nginx latest. Let's give it the tag as well, it doesn't really matter. The port number, if you want to specify here, specify. This is just for the description purpose, because this doesn't really do it. It just simply says that okay, the app is gonna be running on port 80. It does not mean that it will be running on this port 80 will be responsible for running Nginx on port 80. Not really. Nginx by default runs on port 80. This is just for the description purposes now. If I just simply run this, hopefully nothing's gonna change. One more thing, kubectl run Nginx, that's fine. Image is this, port is this. Let me add labels over here as well. So I'm gonna be adding labels, and labels is gonna be app and app Nginx, just like this. So ultimately I have added a label here too. Nginx got created, so pod got created, k get pods. So this is the pod that has just been recently created. So let me add one more thing here, just a sec. Coming back to this one, my notes actually. Earlier I had just this much, kubectl run Nginx image and all. I'm gonna be adding one more thing, that if you want you can even add labels here. So labels, not logos, labels are gonna be equals to app and Nginx, just like this. You can even add the label. Doesn't really matter again what is the use of the label, we will be talking about it soon. Ultimately what happens, that there is something called ReplicaSet. ReplicaSet is responsible for managing the pods, and using the labels only, ReplicaSet selects the pods. So ReplicaSet is the main manager that manages a lot of pods. But how will ReplicaSet recognize the pods that belongs to the ReplicaSet? It uses something called labels, and on the basis of the labels it just simply recognizes the pods and all. So this is how it just simply goes on. Coming back to this one, if I say k get pods, again the pod should be running by now. So ultimately there is a pod running, okay, which I can even run k describe pod Nginx pod, and ultimately this is the info about the pod that we got. It's pretty simple. Name is gonna be this, namespace is this, priority 0, surface node, it is running on local cluster worker 1. So ultimately it is a local cluster, the local clusters worker 1, so it is running over there. the label app nginx, that is set. And apart from this particular thing, there are some IPH stuff and all. Inside this pod you have containers, and inside that particular containers there is only one container running, and that is the nginx pod. Later you can run even more, that's not really a big problem. Even I will show you how you can do that, but overall this is how we just simply go ahead. These are some of the messages, the events that happens here. So first of all you create it, after that you pull the nginx image, after that you start the image. So ultimately once it is pulled, then you start the container, then the container gets started and all. So all the logs you just simply get over here, and number of things you can just simply go through it as much as you want. Okay, so this much we have gone with. So k get pods, we have pods, even we can get the logs as well. So k get logs, and I want to get the logs of nginx pod that I have. Nginx pod is running nginx container. So if I just simply run this, well, there is a problem. So not k get logs, just logs should be enough. So k logs nginx pod, and I'm just simply getting the logs of the nginx. As simple as that. Let me just simply create again. And apart from this particular thing, what else can we do? The next thing is we have already gone through quite a lot. So we know how we create a pod. Let me see if I'm missing something, otherwise we'll just simply go ahead from here on. So we know about clusters, we know about nodes, images, containers, even pods we have covered right now. We even know how we can run the nginx. And not only inside the Kubernetes, you can even run the nginx directly in your main device. So if I want to run nginx, if I talk about the Docker images, so I have only one image right now. If I wanted to get the image of nginx, I could have got that here. So let me run two images here. First of all, Docker run, I'm gonna be running it on, again I will have to specify the port number. So the port number, I should be getting the request at port number 3000, and inside the container the image will be, the container will be running on, not even the container, the service, the app will be running on port 8. So inside the container, the server, the service will be running on port 8, that will be exposed to port 3000 on my local device. And what I want to run, the image I want to run, that is nginx latest. I wanna run in the detached mode, and I wanna give it the name as well. So let's give it some name too. So 3080, name is gonna be nginx nginx app. I'm running it on my local machine, keep that particular thing in mind. And apart from this particular thing, in the detached mode, and the image name should be nginx latest. This is how nginx latest, this is how it's gonna be going on. Let's simply run this. So what will happen, this particular image will be pulled. So it will be pulled from Docker Hub to my machine, and once it is pulled, it will just simply start running, and then we should be able to see the result on port number 3000. Similarly, I'm gonna be running two more images, two or probably just one more, and that's gonna be httpd. I mean, I don't really know what it is, but it runs on a port 80 as well. So the way nginx runs on port 80, it runs on port 82, and it gives you, it works, this kind of a screen. And exactly what is the use of it, I'm not sure. I will be just knowing more about it in future, but at least I can pull the image, check the result, and what else. Okay, so if I say Docker process status, this image is already running, so ignore these ones. These are the cluster related nodes that are running. This is the nginx app that is running, and I'm gonna be getting the result on port 3000. So let me go to my local machine, and this time I will be going to localhost and 3000. And if I say, so I'm getting the result, welcome to nginx, that simply means nginx is running. Apart from this particular thing, let me get one more image over here, and that is gonna be the image of httpd. What is this? I have to know more about it, but ultimately the name is gonna be httpd app. I will be knowing exactly what it does, but it runs on port 80. It gives me some result. Okay, that's what I know. And I want to get the result on port 3001. I've never used this, but ultimately this is the image. Once you run the image inside the container, you will be getting the response. Usually it runs on port 80. That simply means I'm gonna be getting the result on port 3001 and nothing else. So this is how I'm just simply gonna be going ahead with the things. I hope it does make sense. Okay, it's been done. So if I say Docker process status, so these are the three kind of clusters nodes that were already running. These are the two that I have treated right now. And the important one is httpd. The response I will be getting on port 3001. So on port 3000 I'm getting the response of an nginx. On port 3001 I'm gonna be getting the response of httpd. It works. This is what I get. Okay, what exactly it's used for and all, I have no idea. So let's not even worry about that. The main user, The main goal is to just simply use the images and just simply get the result and deploy them. So I'm gonna be doing working on this only. So I hope this much is done. And apart from this particular thing, we have done what? We have described it. Have we described it? I don't know. We've checked the logs. We have created the images. That's great. We have even described it. We haven't deleted any image. So let me even do that. It's pretty easy. So what I mean, if I say, if you get say run k get pods, so you are gonna be getting all the pods. There's only one pod is running right now, and in that pod, what is happening? Wow, I just forgot that I ran these two images on my local device. So let me just simply stop them. So docker process status, if I say, so I have these two images, I'm gonna be stopping. So docker kill, I'm gonna be killing what? I'm gonna be killing first of all this Nginx app that I have. It was running on my local device, and I'm gonna be killing this HTTP app that I have. It was running on my local device. Let's simply run. Both of them have been killed right now. So docker process status, I should be getting only 3 clusters over here. That is it. Ultimately nodes. Okay, so this particular thing is done. Docker process status for all. Let me remove them from here as well. So docker remove, I'm gonna be removing httpd app, and I'm gonna be removing nginx app, and this is how things are gonna be going on. That's it. So they've been removed. Docker process status for all. So this is how I'm gonna be going ahead. What is the next thing that I can do? We've done this much, right? The next thing is that we already have a pod. So k get pods. So I already have a pod. I can even describe this pod. Describe in the sense know more about the pod. I think we already ran this command. So describe and pod. I'm gonna be describing nginx pod here, and it will give me more information about it. I have already done that. And then you can even delete the pod. So k delete, k refers to kubectl. So either you write kubectl or you write k kubectl. Both of them have the same meaning. They will do the same job. So kubectl get I wanna delete, so delete pod. And what is the name of the pod? Nginx app. This is the one that I want to delete. Well, there is a problem, and I gotta just simply ask the people around me to be quiet. Alright, everybody. I've told enough. Let's continue from here on. So kubectl delete pod nginx app. I wanted to delete it, but there is a problem. What is the problem? Don't know. Kubectl. The command is overall right. So kubectl get pods just like this, and this is the pod that I have. I just simply wanna delete this pod. So kubectl delete. I wanna delete a pod, and the pod name is nginx pod actually. So yeah, it's getting deleted. The last time I wrote nginx app, that was the problem. Okay, so this thing is done. K get pods. If I just simply run this command, I'm not gonna be getting any pods right now. So already this much we have done. What is the next thing that we are gonna be doing? The next thing is that we are gonna be creating the pods using the configuration. Like right now we just created the pod directly. Kubectl get pods, kubectl logs nginx. We have already gone with this. We have even checked this node exactly which node it is working on, running on, and let's continue from here on. So the next thing, kubectl delete pod, we have even deleted that, get pods done. And next, Kubernetes manifest. Yeah, so we are gonna be talking about this manifest file. So how you are gonna be even creating it using the manifest file. That is nothing but an ML file. This particular ML file, the name can be actually anything. Inside that you are just simply telling that this is what you want, then you will apply that and you will get the result. Okay, so this is how we are gonna be going here. So let me copy this directly from here. I'm not gonna be writing it, rather just simply copying and pasting. I will definitely explain the stuff. Okay, so I'm gonna be creating a manifest, or you can call it pod. So pod.ml, right? So vi and pods.ml, just like this, and it will be responsible for creating that. By the way, let me copy the whole code from here. Can be anything, it doesn't really matter. Let's simply paste it here. And what we are doing here, first of all, at the top we have API version. What we want to create, we want to create a pod. What is the metadata? Metadata is the name should be nginx, because our name can be nginx pod as well, because of course we are creating the pod over here. So let me name it nginx pod. It doesn't really matter. Even in my notes I would like to name it nginx pod. Why not? So nginx pod, this is the pod that we are creating. The label should be app nginx. What is the use of label? With the help of label only, replica set will be recognizing the pods, right? How you can find the right pod, how you can find the pod that belongs to you. So you will be how that pod belongs to the replica set. So replica set will be finding the pods based on the labels. So this is how it's gonna be going on. And when it comes to specs, by the way, why am I here? Let me be back here. And over here I have specs. Ultimately I'm gonna be having a container inside the pod. So ultimately there can be actually many containers, that is why it is in the plural form. And right now I have only one. The name should be nginx, image should be image will be nginx, and port is gonna be port 80. Again, the port can be port 80, port can be port 443 as well. So ultimately it is just for the description purpose that it is gonna be running on port 80. It doesn't mean that if you don't provide it, it will not run. It will still run. Okay, and let me give it a better name here. It's gonna be nginx app. So the name is nginx app. The image name is nginx app. The image is gonna be nginx. The app is already set to. This thing is this problematic. It will throw the error. So let me make it like this. It should be fine. And once I have done this much, let me just save it, and it should be enough. By the way, let me change this name over here as well. As for this name, I'm gonna be naming it nginx app. Why? It it sounds good. As simple as that. It's completely your choice. Okay, so we have done this much. We have pods.ml, and if you actually have a look at pods.ml, so these are the things that you have inside this. What we are gonna be doing, we are gonna be just simply applying it. So let me clear the terminal. Kubectl apply. Either you write this or just simply write k apply. And what is the file? The file name is pods.ml. Run this. Pod got created. Let's see. So k get pods, and here you have a pod running, nginx pod. This is the pod name, and one by one you wanted one pod, you have one pod running, and that is it. This is how it just simply goes on. And apart from this particular thing, if you try to get a k get nodes, you already have these 3 nodes, you already have one pod running. The question is, what is running inside this pod? Let's simply check this thing out. So k describe pod and nginx pod, just like this. And if you actually run this, so at the top you are gonna be getting what, the name and all, and the node it is running on cluster, local cluster worker. That's great. And the label is app nginx, and the container is the nginx app that is running. And some extra info you are getting, that this is the image name, this is the port 80 TCP. It is just simply for the description because it directly runs as well. You don't really need to worry about that. Some of the logs that you have over here, and that is it. So these are the things that you get. Interesting stuff. We have done that. What is the next thing that we can do? The next thing is that you can even run 2 containers inside the same pod. So if we just say name, and name is gonna be this time Mongo app, or what I had HTTP app, right? That also runs on port 80, but there is a problem that MongoDB runs on 27017 port, and HTTPD it actually runs on port 80 actually. So nginx is already running on port 80, it will also run on port 80, so that's gonna be problematic. So what can I actually do? That just a minute here. Just a minute, I'll be back. Let me just ask them to be quiet. It's a lot of noise around me. Alright everybody, hopefully now there's gonna be no noise at all coming going forward from here. So what are we gonna be doing next? So ultimately we have definitely we were trying to run one more container inside the pod. So this is the pod that we have, and inside this I'm gonna be running Mongo app here, and the image name is gonna be Mongo. Name it latest, it doesn't really matter. I can even add latest over here as well. I mean, who cares? Okay, and then apart from this particular thing, there's gonna be a port. Again, this port is just gonna be for the naming purpose, because it will run on the port that it has to run. It will not really care exactly whether which port you have mentioned over here. What is the port? 27017, I think. I hope this is the port. This is the configuration that we have over here. Even in my manifest.ml, I'm gonna be just simply replacing it, and hopefully it's gonna be working fine. Okay, so let me just simply do one thing. ls I already have a cluster running, so pod running, so get pods. So this is the pod that is running, and let's change the name of it as well. But that's gonna be problematic. How can I change the name? By the way, pod cluster Kubernetes. Let's simply name it pod cluster pod. Cube pod, just like this, Kubernetes pod. So ultimately this is gonna be the name of that. Hopefully it will not be problematic, because the name is already here. Most probably a new pod will be created. That simply means I will have to stop this. So let me run this, and then I will be stopping the previous one. Okay, so what will I be doing? Kubectl, so apply. I'm gonna be applying apply. File is gonna be pods.ml. Let's simply run this. A new pod got created. The name is cube pod. Okay, and right now get pods. If I just say, so I have 2 pods running, and in the new pod that is being created, inside that I have 2 containers running, and out of those two containers, 0 are running right now, but soon both of them are gonna be running. By the way, still container is still getting created. Let's wait for a while until it gets created successfully. We will actually have to wait for a while. It will just simply pull the images and all, and then it will start running, if I'm not wrong. But right now both of them are running. That simply means MongoDB is running as well. This is the kube pod. Inside that we have MongoDB running, and we have Nginx running, right? Let me delete this particular pod right now. So I'm just simply gonna say delete pod and Nginx pod, just like this, and it's gonna be deleted. Okay, now if I try to get the pods, so I actually have just one pod, cube pod, that is running. So talking about the things that I have so far, so get clusters. I have one cluster, local cluster running. Get pods. I have one pod running. Get nodes. I have these nodes running. Get rs replica set. I don't have any replica set. Get deployment. I don't have any deployment. Get services. One service runs by default. I can even say get SVC actually. So one service runs by default. So these are the things. Okay, that's fine. Let's simply get the get pods again. So this is the pod. If I describe the pod, so I can even check the logs. Okay, let's first of all describe the pod. So describe pod, which is the pod, that is the cube pod that is running over here. Once I describe it, so I will be knowing about each and everything. Let's simply go here from the top. So first of all, this is the name, the default. It is running on local cluster worker 2. So it is running on worker 2 right now. The name is app nginx. That's fine. The label can actually be anything, but as I have named it app nginx, so let it be here. Inside the containers, I have 2 things running. First of all, there is nginx app running. The another one is Mongo app running. So ultimately 2 things are running inside the same pod. And when it comes to logs, so we have first of all nginx image containers started running, and then MongoDB image containers started running. So this is how it just simply goes on. If I just try to get the logs, okay, get logs. By the way, I will have to even, it should not be logs, logs, and I'm gonna be getting the logs of cube pod, just like this. So by default I will be getting the logs of nginx. Why? Because nginx was the first one. So it is just simply saying that defaulted container nginx app out of nginx app and Mongo app. We had 2 containers, nginx app and Mongo app, and the default container is nginx app, and that is why we are getting the result of nginx. What is the next thing? If I wanna get the logs of MongoDB, so I have to just simply have this I have to just write -c stands for container, and that's gonna be Mongo app actually, and this time I'm gonna be getting the logs of Mongo app. Similarly, if you want to specifically mention that I want to get the logs of Nginx app, so you are gonna be getting even that. So this is how it's gonna be going on. Hopefully we have gone through quite a lot. And what is the next thing? The next thing is that you can just directly delete the app as well. And if you want to delete the app, pod, so k get pods, these are the pods that you have, and if you want to delete them, you already know, you can just simply write k delete pod, and you can just simply mention the cube pod, and the pod is gonna be deleted. Okay, we can do it anytime, but I'm not really gonna be doing it right now. So hopefully, or let's do that, why not? K, we can just create anytime. So k delete pod and cube pod, and this way pod is deleted, k get pods, we don't really have any pods as such. Okay, so we have gone through these many things, interesting stuff. Let's go through the another one, like clusters. We already know about all these things. Going forward from here, now we are going to be learning about deployment. So what is the deployment? But before even deployment, so ReplicaSet is mainly responsible for creating the pods, ultimately managing the pods. ReplicaSet will be responsible for creating new pods, deleting the pods that crashes, recreating the pods for them, updating the pods. So ultimately all these things are going to be done by ReplicaSet. So ultimately this is the job of ReplicaSet. ReplicaSet will even maintain the number of pods. So you will specify your desired capacity, like how many pods you want, and ReplicaSet will make sure that the number of pods don't exceed that, or the number of pods don't get less, don't be lesser than that. So this is how these are all these things are gonna be handled by ReplicaSet. And what is deployment? Deployment is just higher level manager that is responsible for creating ReplicaSet. So deployment does nothing, it just simply creates ReplicaSet. In turn, ReplicaSet create pods. And why we have deployment? Because whenever you change something, deployment will create a new ReplicaSet. In turn, ReplicaSet will be creating new pods and all. So ultimately, deployment is mainly responsible for deploying the stuff whenever you make some changes. So at the time, deployment will be responsible for creating the new ReplicaSet, and that ReplicaSet will be creating the new pods and all. And this is how the things go on. Having said that, we have already talked about all these things in detail. So let me directly create ReplicaSet, and then we will be creating the deployment. And this is how we are gonna be going ahead. By the way, there are some keywords here. You better know about them. But first of all, we are gonna be talking about ReplicaSet over here. And when it comes to ReplicaSets, what is this? Kubectl creator deployment Nginx. Okay, you can create it directly. That's fine. And apart from this particular thing, there's nothing. And then time to go with the ReplicaSet. And once we have gone with the ReplicaSet, we will even apply that. Once that's done, we'll just dive deeper into that. And apart from this, then we will even delete the ReplicaSet. And once everything is done, then we will be switching to the Nginx. Deployment. So kubectl delete pod Nginx. So all these things. Kubectl run. This is also done. Kubectl delete rs Nginx. Alrighty. So the next thing is gonna be what? The next thing is gonna be about ReplicaSet. So what is the ReplicaSet? I have already talked about that. So we have already covered clusters. We have even covered the pods. And when it comes to this, we have gone through all these things. API version. Even I've talked about it exactly what it does and all. And lastly, we manifested. Ultimately, we use the file name. Ultimately, we use the configuration to just simply create the pods. And lastly, we deleted the pod. And this is how it just simply went on. By the way, this should be not Nginx, this should be Nginx pod. That's the name. Okay, and once these things are done, then that's it. You don't really need to worry about it. So these two things are done. Let's talk about ReplicaSet. Again, this is the configuration. What will I do? I'll just simply copy and paste. Don't worry about the name. Name can actually be anything. So I'm gonna be creating a file here again, and that's gonna be virs.ml. Again, either you write yml or yml, both of them are the same. Okay, what will I do? I'll just simply copy it from here, and I'm gonna be pasting it over here. What it does? Let's start from the beginning. The version, simple. Kind, I want to create the ReplicaSet. Metadata, this is the name of the ReplicaSet. So Nginx ReplicaSet. Should it be Nginx ReplicaSet? This ReplicaSet will be responsible for creating the what? Creating the pods. In turn, those pods will be responsible for running the Nginx. So that's okay. Let's name it Nginx ReplicaSet. Doesn't really matter. The name depends on your application, what kind of service you are actually providing. We want 3 replicas. Ultimately, I want 3 pods running. Right? It will create a 3 pods, and those 3 pods will be running 3 containers and all. This is how it's gonna be going on. Again, here as well, if you want, you can run one container, you can run many container. So inside a pod, it's completely up to you how many containers you want to run. And we are just simply saying that okay, we want 3 replicas. Selector. This replica set will be selecting the pods based on this particular label, because replica set is responsible for managing the pods. That simply means it is responsible for creating, deleting, updating, all these things. And how will it find those pods? It will be finding them based on this particular label. And then template, I'm just gonna be creating a pod here on the basis of this particular template. Metadata should be this. Inside the metadata, I'm adding the label, so that replica set label is gonna be app nginx here. So replica, because I have added this label app nginx over here, so based on this label, replica set will be finding the pods. And apart from this particular thing, containers, nginx and image nginx, ultimately I want to run nginx app. Image should be nginx latest, port number should be this, and that is how it should be going on. By the way, it can be nginx app as well if you actually want to be clear, because this is gonna be nothing but the nginx app. And that is it. By the way, once I save it from here and kubectls, okay, apply, file name is gonna be rs.ml. So what will happen? A replica set will be created, and this time if I say k get pods, k get rs, so I'm gonna be getting the replica set. So this is the new replica set got created. That replica set is responsible for 3 pods, so it will be responsible for creating 3 pods, and it is just simply saying that desired capacity was 3. 3 of them are like currently running, and 2 of them are ready. Let me write one more time. All those 3 are gonna be ready by now. So this is how it just simply says k get pods. If I try to get the pods, I have 3 pods running over here, and all those, it is just simply saying that replica set this, replica set this, replica set this. Ultimately 3 pods are running, and all those pods are just simply doing nothing but running the nginx app inside them. If I try to delete a replica set, what will happen? Sorry, if I try to delete a pod, what will happen? Replica set will create the pod again, because replica set simply says that I want 3 pods to be running. If I have 2, I will create 1. If I have 4, I will delete 1. Ultimately, there should be only 3 replica sets running at a time. So if I want to delete, suppose I try deleting 5, 4, M, 7, 8. What will happen? Let's see. K delete pod. What I want to delete? K stands for kubectl, again refers to kubectl. Again, I'm saying don't get confused. By the way, k delete pod nginx. This I'm gonna be deleting this. This has been deleted. If I try to get the pods right now, you would actually see earlier I had this one. Now that got deleted, so I got a new one. So QS and WB, they were already here. They were already here earlier. They are here right now even as well. But the last one that I deleted, a new pod got created 3 seconds back, and a new one I have over here. So replica set makes sure that if you are creating more than that, it will decrease the number of pods. It will, if you are deleting some, it will recreate them. If I try to create a replica set, sorry, pod. So k run nginx app, and image I will be using, that's gonna be nginx latest. The important thing is that you will have to add the label over here. Because of this label only, replica set will be able to recognize that this particular pod belongs to me. If it doesn't belong to the pod, if the pod doesn't belong to the replica set will not be deleting that. If it does belong to the replica set will delete that, because replica set already has 3 pods running. It will not have the 4th one. So if I say labels app nginx, it is just simply saying that it got created. If I check the pods, I only have 3 of them running, and the new pod's name was nginx app. I don't really have it here. Why? Nginx actually deleted that. So if you actually check the logs of it, replica sets, okay, logs of nginx replica. Hopefully I will be able to get the log. Well, no, it's not really possible. You can't really get the log of it, but never mind. If the label is different, suppose nginx 1, right now the label is different, so replica set will just simply say this, the label is different. That simply means it doesn't belong to me. Let it be created. So if I try to get a k pods, get pods, So I'm gonna be getting the nginx app right now because the label is different, and this particular nginx pod does not belong to the replica set. These three belongs to the replica set, but this new one does not belong because the label is different, and on the basis of the label only a replica set recognizes the pods and all. And that's it. If you want to delete all of them, k delete pods all, what will happen? All of them will be deleted. But because replica set is running right now, replica set will recreate these three, and this will be deleted forever. Replica set doesn't really care whether this exists or gets deleted. Run it. All of them have been deleted. Now if I try to get the pod, new ones are gonna be created because replica set is still running. So k get pods. Yeah, these new ones RF499, they were not here earlier. Were they here? Not really. These are the new pods that are created 10 seconds ago. As simple as that. So even if you delete all the pods, replica set will be recreating them, because replica set says I need 3 pods anyhow running. If I have less, I will create. If I have more, I will delete. If I have equal, I mean exact, I'll do nothing. I'll sit and relax. Okay. So this is how this simply goes on. Let's simply clear it from here. So we have even covered this replica set nginx deployment. We can even delete the replica set. I will be doing that. And as soon as you delete the replica set, your pods are gonna be deleted automatically. And apart from this particular thing, let me check if I'm missing something or not. So yeah, we are not really missing anything. So if I say k get pods, so I have these pods. K get replica set. I have this replica set. K delete replica set, and I'm gonna be deleting nginx replica set just like this. If I run this, replica set has been deleted. K get rs, no replica set. K get pods, no pods. I said pods, what depends on you. K get nodes, I will definitely have the nodes. It doesn't really matter whether I have the pods or replica sets and all. Pod will always be there. Nodes will always be there because they were created by, they are the nodes, right? They are the cluster nodes. If I delete them, they will also be deleted, but I haven't deleted them yet. Okay, so this thing, this particular thing is done. And what is the next thing that we are gonna be talking about? The next thing is that that we will be talking about here. That is the deployment. Now, why do we need deployment when replica set was handling everything, right? So why we need it? Let me tell you this thing exactly. So we need deployment because deployment will be responsible for creating the replica set. So here we created the replica set manually. Now we will be configuring everything inside deployment. It will be responsible for creating replica sets, and replica sets will be responsible for creating the pods. Pods will be running the containers. Those containers will be running some kind of images and all. Okay, so this is how the overall flow is. And why do we even need this? Because replica sets were doing the same job, right? Almost replica set was handling everything. So why do we need deployment? It is important so that whenever you are gonna be making new changes in the deployment, you earlier suppose you had version 1, now you made some changes, and right now you are gonna be having version 2. So how will you make sure that version 2 actually takes effect? In that situation, a deployment will be responsible for creating new replica set altogether. So new replica set will be created. Once new replica sets are created, new pods and containers, all these are gonna be created, and they are gonna be the new ones. So this is how deployment will be creating the new replica set. In turn, replica set will create the pod, containers and all. And after that, deployment or replica set will check whether the pod is actually running well or not. If pod is not running, deployment will keep the previous replica set pods, containers, images chain active. That simply means previous pods will be running. And if everything goes well on this side, the new version side, then previous ones are gonna be deleted in a rolling format in the sense, first of all, one pod will be created here of that version 2. Then if it runs successfully, then one pod will be deleted from version 1. Then another pod will be created here, another one will be deleted from the version 1, and this way it will just keep rolling one by one. Okay, so this is how the things go on ultimately. Let's talk about this deployment stuff, exactly what it does. So talking about this deployment, again replica we have already gone with. These are some of the commands. Kubectl apply this. This is how you can apply it. You can get the replica set like this. You can get the pods like this. You can delete the pod like this. We know how to delete a pod. You can again get pods. I'm getting the pods 2 times crazy. Never mind. kubectl run nginx. This is how you can just simply even create a new pod. Then you can delete the replica set, delete all the pods forcefully and all, and this is how it just simply goes on. So we've talked about clusters, pods, replica set, deployment. Again, the name can be anything. Let's name it deployment.ml here. So vi, keep in mind, k get pods, do I have? No. K get rs, do I have? No. K get nodes, of course I have. Okay, and what will I do? Now I will create deployment. I will run this particular file, and what will happen? This will be responsible for again, whatever I'm doing using this configuration file, you can just run the same command for that as well. But writing the configuration file is easy, as well as this is what is used in production. Let me copy it from here. Vi deployment.ml. And if you are thinking like, how do you know it's used in production? The stuff is simple. Who will write the commands over and over and over and over? As simple as that. So if once you wrote the ML file, configuration file, that's written. You have to just simply apply that. But when it comes to writing the commands, you will have to write it from scratch again and again, and that is why we just create the ML files and all. Let me just simply paste it here. And once it's done, we are already running only one container. Again, it's exactly simple. First of all, what am I saying? This is the version. What is the type, kind, that is deployment. What is the metadata? The name of the deployment is nginx deployment. Coming back to this one, how many replicas do you want? How many replicas in the sense, how many pods do you want to be running? And ultimately, deployment will not be responsible for running the pods. Deployment will be responsible for creating the replica set. Replica set will be responsible for creating the pods and all. But ultimately, I have to specify it over here, right? So I want 3 replicas. Selectors, when it comes to selectors, so how will it be selecting the pods on the basis of this log? What should be the template of the pod? The template of the pod is this, where I'm specifying the label, and the spec is gonna be containers. There's gonna be only one container running. Up to you. You can run one container, you can run many containers, completely up to you. And let's simply save it here, and let me run this command here. K apply f and deployment. Run this. And it turns out we are getting the error because that is not ap, that is apply. Let's simply run this right now. And if I try to get nodes, I already had nodes from the beginning. K get replica sets. Sorry, not even replica sets, deployment. Let me try to get that. I have one deployment. I wanted 3 replicas. We have all the 3 replicas. That simply means it will be creating 3 replicas, and all the replicas are here. Replicas in the sense in turn pods are gonna be created, and at the end it is just simply saying that all of them are running, and what will be the manager for managing the pods? Replica set. So let me check whether I have the replica sets and all. So k get rs. I do have a replica set that has been created by nginx deployment. So the name, this is the nginx deployment. Nginx deployment slash hyphen some gibberish. That simply means this is created by deployment only, and this is the replica set. The desired capacity was 3. Current capacity, current number is 3. Ready are 3. That simply means 3 of them are running. If I get the pods, okay, get pods right now. Oh well, these 3 are running well. Interesting, great job. What is the next thing? The next thing is that if you make any changes, this is the deployment ML that you have. And why did we use deployment ML? So that in future, if you are making any changes in the sense, if you are saying that now I wanna run Mongo app, the image is gonna be Nginx. This is the new version, right? So in Mongo latest, and ports are gonna be container port, and that's gonna be 27017. Suppose you suddenly thought that okay, inside the container I want my Nginx running, that's okay, I want even MongoDB app running, just like this you want to just simply go ahead. So what will you do? You said okay, I have already configured everything inside this, let me run k apply f and deployment. Done. You have applied it, but the request got invalid. Why? No. It should be fine. What am I missing? Mongo app. strict decoding error, unknown field, spec fields, spec error. Okay, there is a problem in the configuration. Never mind. Let me. Now it should be fine. I mean, maybe it wasn't formatted well. Well, no, it is not like that. So in that case, inside the containers, I have two things running. What is the problem with this? The problem with this is that I'm trying to create a new image altogether inside that. Rather, I should be changing some things here only. So there should be some new versions of Nginx. Suppose I create a new version. Suppose version 1. Okay, this way. So definitely new pods are new replica set will be created, then new pods will be created, and then we will have to roll back, because of course this is gonna be throwing the error and pods will not be created. So at least we can do this much. So let me try it again, and then it got done. So k get rs. So now I have two replica sets. This is the new one that got created, and if I get the pods, so I have these new pods being created, but we are getting the error over here. It is just simply saying that error image full. So the replica set that we got, even it is not working, it's better to just simply delete this replica set. The simple reason is that the new replica set that I created, there was a bug, sorry, the new changes that I made in the file, in the new version, there was a bug in the new version, and because of that thing, it tried to create the new replica set. Deployment tried to create. In turn, replica set k get pods. Replica sets tried to create the image as well, but at the end, image pull back off. Ultimately, image wouldn't be pulled, and because of that thing, we got the error. That simply means as the new version had some bug, and because of that thing, it could not create the and run the image properly. The previous ones are still gonna be running successfully. If it succeeded, then previous one would be stopping one by one, but as it is not succeeded, rather it failed, so previous ones are gonna be just simply running, getting the traffic and all, and this is how it just simply goes on. By the way, ls, let me get it back just like this. If I just simply run it one more time, so this is how it's gonna be done. K get pods, k get rs. So right now what happened, new replica set got created. Ultimately the previous one is still running because there are no changes as well. As simple as that. As there are no changes, so the previous one is still running. And as for the pods, so k get pods, I have the previous pods running right now. K get rs, let me remove this rs, k remove k delete rs, and this is the name of the rs replica set. Let me delete this from here. It's gonna be deleting k get rs. I have only one replica set running, and I hope you got the idea exactly how the things are gonna be working. Alrighty, so we have talked about all these things right now. Let me see if I'm missing something. Give me a moment, I'll be back. Just a sec. Hello. Okay, let's continue from here on. So these many things we have done. That's great thing. What is the next thing that we are gonna be doing? Right now, this is gonna be the time for talking about the deployment and all. Real creating the Kubernetes on AWS and getting this stuff done. I will be even showing the process exactly how you can get it done. Yesterday I spent a lot of time figuring it out because it's a bit complex. It's not like straightforward going and clicking a button. Rather, that's not. I mean, I'll be showing exactly how it happens and all. And kubectl delete pod index deployment. Let me even delete the deployment get pods. Even it's gonna be deleted. Kubectl get pods. Yeah. Let me at the end k get deployment. I have this k delete deployment and nginx deployment. Let me delete this k get deployment, and right now I don't have any deployment. That simply means k get I don't have any rs, k get I don't have any pods, and I don't have nothing as such. Okay, so this particular thing is done as well. What is the next thing that we have to go through? Why do we need why do we need a deployment? Does it okay, update image to Nginx 2. We already know why do we need deployment, so let's not worry about that. And apart from this particular thing, rollout deployment ensures that there is a smooth deployment, and if the new image fails or for some reason the old replica set is maintained, even though replica set is what does pod management, deployment is what does replica set management. Yeah, simple. Deployment manages replica sets, replica sets manages pods manages what pods manages containers. Kubectl rollout history deployment. Check out the history of the deployment. So if you want, there are few commands here. Undo the last deployment. This is good stuff. I will be trying it out later, but for now because I have deleted everything, let me just start it. So kget not kget, k apply file name is gonna be deployment.ml, kget deployment. So ultimately we have new deployment over here, and right now if I want to check all the history, so kubectl rollout history deployment nginx deployment, and this way I'm gonna be checking the history. So if I just run this, so it is just simply saying that there is no history as such, no change call. So ultimately I did not change anything, but this command is used for getting the history. And there's I have one more command, and that's gonna be this one, kubectl rollout undo deployment nginx. So it just simply undoes your your changes that you do. So if I just simply run this, no rollout history found for the deployment. So it simply means that if you are making some changes and then if you are creating new replica sets, so if you want to go one step back, so ultimately you can just simply run this command. So this is how it just simply goes. Having said that, I'm gonna be saving it in my notes as well. So first of all, we talked about this, as simple as that. We have already gone through this. We can get the deployment, we can get the replica sets, get the pods, apply the deployment, roll out undo. So roll out undo deployment nginx to revision 1. This is just for the version, how many versions back you wanna just simply go. And you can scale the replica sets. So like we have what replica is set to 3 right now. So if you run this particular command right now, kubectl scale deployment nginx replica 1, that simply means one replica will be set automatically. And apart from this particular thing, there are few commands. So let me just simply copy these commands over here. So this is the first one, that is mainly for getting the history, as simple as that. So if you want to get the history, so this will be used. And if you want to check the undo the steps, so this will be used. So ultimately undo the last deployment. And again, don't worry, like even I just make the things really, I save the things really well. I create my notes really well, so that in future if I get stuck, I can just simply come back here and just simply get the reference. And as you keep working on with the things, you just sort of they get saved in your mind, and you just simply need to make a Google search, you will get that, and just simply go ahead with that. Okay, by the way, and history, get the history of deployment. Okay, so this is how it's gonna be going on. You can just even get the like all kubectl get all, you will be getting all, like you will be getting the pods, you will be getting the deployment, you will be getting the replica sets. Here you will be getting everything. And kubectl delete deployment, this is how you can just simply delete it as well. And create new deployment, we have gone through that. And what am I doing over here? Replica set 3, metadata, nginx, that's already done. Anything else that I'm missing here? Kubectl logs of nginx deployment this. So I'm gonna be getting the logs of this. Here data is initialized and super user password is not specified. You must use for this. Okay, fine. Postgres forward to non-empty value for the super user. For example, like this on this. You may not also use Postgres or host auth to allow connections without a password. This is not recommended. See Postgres. Okay, documentation. The simple thing is that we can even run the Postgres SQL. Can we do that? Nginx. And what am I doing here? I want to run the image Postgres container name Postgres and your value password. So ultimately you can run the Postgres as well, and you can just simply provide your environment variable. Let me try to do this. This is gonna be really interesting. By the way, you can run this command to just simply get all the things. If I run this command, I will be getting everything, like the replica set that I have, the deployment that I have, and then few pods, the pods that I have here. So ultimately it just simply returns me everything. And this is how you can just delete the replica set. How will you get the name? You are gonna be getting the name from here. So if you want to delete the deployment, so you just copy it and delete it. So this is how it's gonna be done. And then apart from this particular thing, you can even run more containers inside that. So you can run 2 containers, and you can even create the replica set, I mean deployment directly. It's pretty simple the way you are creating it using this. The same way you can create it using the command as well. And then you can apply that. You can get the deployment, get the replica set, get the pods, and get the logs of Nginx by default, get the logs of Mongo, get the logs of Nginx. So this is how things are gonna be going on. One more thing that I wanna try here, that's pretty interesting stuff. Let me just first of all write the code here, and that code is this. I will be explaining it, don't worry, but it's pretty simple. Running PostgreSQL, just like this. Okay, so ultimately deployment file you are creating here. What we are doing, time deployment, metadata Nginx, that's fine, Nginx deployment. And replica 3, I want mesh label app Nginx, that's fine, app Nginx. And it turns out that, oh yeah, name should be Postgres DB, and app should be Postgres, or app Postgres. Okay, this is gonna be the label, and Postgres DB, Postgres latest container is gonna be port 80. 5432. By the way, it doesn't really matter like whether you specify it over here or not. Postgres password I need to provide, and Postgres value name, Postgres password value. So I need to provide Postgres password over here. And apart from this particular thing, anything else? So ultimately I will be running Postgres database. So ultimately Postgres will get the password. Yeah, it should automatically be created. Let's see. Okay. Is there any problem? Capital container creating Postgres is gonna be created. Nginx deployment, Postgres is running correctly. Let's see whether if I run this much, hopefully Postgres should be created. Error database is initialized and super user is not specified. Kubectl Nginx. You must specify Postgres password to a non-empty value for the super user. For example, if Postgres is gonna be equals to on Docker run. So yeah, on Docker run we do that. You may also use Postgres host auth method cluster to allow all the operations without. Let's see whether it works or not. Let me copy it from here, and I'm gonna be creating one more deployment. So vi deployment postgres.ml. Let me just simply paste everything over here, and get deployment. Oh, I already have one deployment running, so let me delete this. Okay, get this time I'm gonna be getting all. So get all. And this is the deployment that I have. Let me just simply copy it. Okay, delete. Okay, delete deployment. That's should be fine. Okay, get deployment. Yeah, I don't have any. Get ReplicaSets rs. Get pods. I mean this way I'll keep going. Get nodes. I definitely have the nodes. Okay, that's great. What is the next thing? The next thing is that I want to run another replica set here. Sorry, deployment here. So apply file name is gonna be deployment and Postgres ML. This is how it's gonna be going on. Let's simply run this. Is invalid. App Postgres selector does not match the tables. Okay, let me correct that. So what needs to be corrected here? That is this one. It will be matching based on Postgres. First of all, this, and the label should be a Postgres over here as well. Postgres DB. Let us define your password. Postgres 1234, and that is it. Let's see how it's gonna be going on. By the way, I need to just change this here as well. I did not really change this. Postgres deployment, and that is it. Coming back to this one, let me just change a few names here. Postgres, just like this. And if I try to run this, then it should be running. Hopefully, get a deployment. Okay, I don't have any. K apply. File name is gonna be deployment, and this it has been created. K get deployment. So ultimately, I needed 3 replicas. Out of them, 0 are running right now. K get replica sets. Okay, 3 current, 3 desired, 0 are running. So ultimately, no pods are running. K pods, get pods. Oh, right now even pods are running. So K get deployment. So right now 3 by 3, all of them are running. Apart from this particular thing, K get replica sets. 3 were desired, and all of them are running in the ready state. K get pods. We have 3 pods over here, and if I just get the logs, so K get first of all, let's describe them. So K describe pod. This is the pod name. This is the name of the deployment. This is the, and this much is the name of the replica set. This much is the name of the pod. It combines all. So this is the configuration that I've got over here, and it is just simply saying that this is the name, this is the cluster name, this is the label, and inside the containers Postgres DB is running. These are some of the logs related to that, and nothing else. Ls, what is the next thing? The next thing is that checking the logs. Okay, logs and okay, logs of what? Okay, logs of this. So these are the logs of Postgres DB. So it actually started from here. Files belonging to database system will owned by Postgres. This user also must own this. You can just simply read more about it. These are the logs of it. You can even follow it. So it will never end. And as you keep getting more logs here, all of them are gonna be visible. Alrighty then, let's simply get rid of it. We have even done this thing. We have run Postgres DB, and it is running quite well. Let me copy this whole thing from here, and at the end of the day, I'm gonna be pasting it here. Okay, pretty simple. Alrighty, we have gone this much. What is the next thing that we can do? The next thing is that creating the Kubernetes machine on AWS and then deploying everything, because so far we have been doing the things locally. Ouch. And what is actually happening here? The thing is simple. What we are doing here? We have our machine. Suppose I have my Linux machine here. Linux machine over here. Okay, once I have this machine, inside this machine I created Kubernetes cluster, right? So ultimately what I created Kubernetes cluster. Okay, this is the thing that I created first, and inside the Kubernetes cluster I had some nodes. So this is the first node, this is the second node, similarly this is the third node, and lastly this is the fourth node. So few nodes I created, and one of them is the master node, and that master node is called the control plane, and other ones are just normal nodes. So this is the normal node, this is the normal node, and this is the normal node. And what is happening inside those nodes? What I did inside those nodes, I created a pod, right? And then that pod got created, and inside that pod I started running the container. Yeah, that's right. So inside the node I have the pod, and the pod is running the container. Inside the container, what am I doing? Inside the container, let's keep it like this. Let me keep them here one by. Okay, so inside this, what am I doing? On port 80 I am running, or on port 5432. Sorry, suffering from message buttons. 5432. On this port I am running Postgres, right? But the question is, how will I get it? Because it is not like it is directly running on my machine, not really like this. This is the Linux machine, and maybe this is the Linux machine. And inside that I have this Kubernetes cluster, and inside that Kubernetes cluster I have my master. How much will I sneeze, bro? It's getting too much. By the way, coming back to this one, So ultimately, usually what happens, I send a request to master or the any node, and I should be able to get the result, right? But what is actually gonna be happening here? Inside the Kubernetes cluster, I have these nodes. Inside those nodes, I have a container running, and inside that particular container, on port 5432, Postgres is running. As simple as that. That simply means if you know the IP address of the container, then you can talk to that. If you know the IP address of this particular container, then you can definitely make a request to that particular node. So ultimately you can make a request to that particular node and you will be able to talk to that. But the thing is that there's no way to get the IP address of it. Okay, ultimately, yeah, of course you don't know the IP address. So how will you even, talk to that? If you deploy it on EC2 machine, not EC2 machine, on EKS, Elastic Kubernetes service on AWS, or on Kubernetes service on DigitalOcean, so they give you the IP address as well. That simply means you are gonna be getting the IP address of the pod or the container, so you will directly be able to talk. But on your local machine, is there any way that you can just simply send a request directly to this particular container? And the answer is that there's no straight way. Well, you can do some logic stuff and all, and you can somehow make it possible to just simply send the request over here. Directly there is no way, and that is why what you do, you just simply deploy it to Kubernetes on AWS or DigitalOcean and all. From there you will get the IP address, and then once you got the IP address, just simply send a request here and the job is done. By the way, the important thing actually comes from here. I have this running on port 5432. Okay, that's great, and this is nothing but the container. I had something in my mind, but I forgot. There was a way. This is my local machine. Somehow, what is my goal? My goal is to make the result of that particular container be available here on port 3000. The question is, how can I expose the result of this particular container? And for this thing, there are services, if I'm not wrong, and that is why services are used for. Let me check this thing out. So going ahead from here, then we are going to be learning about services, and there's something called load balancing. So services are mainly used for this particular stuff, that if you actually want to or even precise, what I can do, whenever I am creating this cluster, okay, so I'll say that, let me see what exactly can I do here, but definitely something can be done. So on digital machine, like on Kubernetes, on AWS, or on DigitalOcean, it's simple, easy peasy, because you will directly be getting the IP of this. You can directly talk to that and the job will be done. The main problem is on local machine, and there must be a way. I heard about that. Let's all ensure this deployment Nginx and kubectl apply. This is also done. We have already gone with this. You cannot get the result directly over here, and then services are gonna become. So in Kubernetes, a service is an abstraction that defines a logical set of pods and a policy by which to access them. So there are gonna be logical set of pods and policy by which to access them. Kubernetes services provide a way to expose applications running on a set of pods as network services. So there are gonna be set of pods that are gonna be running, and they are gonna be exposed as network services. So ultimately, somehow they are going to be exposed. So Kubernetes services provide a way. Kubernetes services, so services that I'm gonna be talking about now. Talking what I will have to even learn it on the go. It's not like I have no idea about this. I know it, but the thing is that knowing more is better, because until unless I'm sure about each and everything, that will not make any sense. So in Kubernetes, the service is an abstraction that defines a logical set of pods and a policy. So I will be defining a logical set of pods. How will I be defining them? How will I create a logical set of pods based on the selectors, based on the labels? So all the pods that have the same label, inside the node there is a pod running, inside this node there is a pod running, inside this node there is a pod running. So on the basis of the selectors, that I specified the label, that I specified no app nginx, app postgres. On the basis, if the labels are same, they are gonna be one set of pods. If the label is different, then they are gonna be different set of pods. So this way, first of all, group is gonna be created, set is gonna be created, and Kube provide a way to expose applications running on a set of ports and as network services. So ultimately, first of all, a set will be created of these containers, and lastly they need to be exposed, and for exposing them we need services. Because look, it's pretty simple. We have a Linux machine. Yeah, this is the Linux machine. Let me even, this is the this is the Linux machine that we have. This is the container that I created. This is the container that I created. Inside that container we have our master. So this is the master that we have. Inside that master we have some nodes here. So this is one node. This is the node number 1. This is node number 2, and this is node number 3. So these are the nodes I have. Now the thing is that inside those nodes there is a pod. Inside that pod there is a container. That container is running the Postgres on port 5432. So there is no direct way to talk to this, because first of all I don't know the IP address of this, and the second thing is that because I'm not exposing anything from here, that simply means I'm not getting anything on port 3000 on my, or any port on my local machine. So there's nothing exposed on any port on my local machine, so there's no way to get the result. What will I do? Now I will create services. What will service do? Service will first of all create a group, create a set of some nodes that have the same labels. Okay, on the basis of the labels, it will just simply select the nodes and it will kind of create a group. Once the group is created, then it will expose that. So it's gonna be just simply exposing the applications running on a set of pods as the network services. So as the network services, they are gonna be exposed. That simply means once they are exposed, you will be able to send a request to this, or this, or even if you are sending a request to this, the thing is that they are gonna be kind of connected. So even if you are sending a request to this, then on the basis of the load and all, or randomly, either this will handle the request, or this will handle the request, or this will handle the request. So doesn't matter which node you are sending the request. If you are sending the request to this particular node, or you are sending the node, or even you are sending the request to this particular node, on the basis of some, I mean, load balancing stuff and all. So ultimately it will load balance the request. So sometimes the request will be, doesn't matter which IP address you are using. You may be using the IP address of node 1, you may be using the IP address of this, or maybe this. There could be possibility that you are going to be sending the request to this, but the request will be forwarded to this particular pod, because they are going to be set of pods right now. Kind of they will be exposed as network services, and this way, depending on the load, depending on the request will be keep getting forwarded to one or the other, and they are going to be just simply handling the request and sending the response. So this is how things are going to be going on. But the question is, how will I be exposing it? So let's talk about the services right now. Here are the key concepts. So what are the key concepts? Let's even talk about that. Pod selector. So first of all, pod selector. What is services use labels to, I already discussed about this, how we select the pods. So services use labels to select pods they target. A label selector identifies a set of pods based on their labels. As simple as that. They have the same labels. So keep the colors in mind. As they have the same colors, that simply means they have the same labels. As they have the same labels, so what will happen? Services. Here we are just talking about the service over here. So this service that we have here. Okay. So this service that we have here. So this service will be doing what? This service will be creating a set of pods. So the pod of this set, and this one. So it will be creating kind of a group on the basis of what? On the basis of the labels that they have, and because they have the same label, what can be the label here? The label can be pretty simple. This has a label app. Suppose app Postgres. It has this label. Similarly, it also has this label. Similarly, it also has this label. So ultimately, they are going to be having the same labels. As they have the same labels, they are going to be grouped together, and they are going to be exposed together. It's not like one of them is going to be exposed. All of them are going to be exposed. And once you get the request, any one of them will be just simply handling the request and all. Okay. So pod services use labels to select the pods they target. A label selector identifies a set of pods based on their labels. Services types, there are 3 types of services as well. It's not like there's only one type of services. We are gonna be talking about 2 of them here, and the remaining third one will be talked about tomorrow. By the way, talking about the services, so we have something called node port. We will be talking about it today. Okay, node port in the sense how you can expose something using the node on your, either on your local device or on the Kubernetes cluster. And even one thing I forgotten, there was a way to just simply expose them on the local machine as well. A bit complex, that is for sure, but it can be exposed on local machine as well. I will be figuring it out exactly how I can do that. If it occurs to me, and if I just happen to know the way right now, I will be doing it right now, or I will be doing it tomorrow. But definitely it's gonna be done. By the way, what is the use of node port? Node port is nothing but a service that is responsible for making sure that using the node port you will be able to access them. As simple as that. So node port will make sure that this is the, what will it do actually. Let me have few more names here, and then I'm gonna be talking about it. So you have node port. Similarly, we have load balancer, and lastly we have something called cluster IP. And I'm gonna be talking about these 2 over here. I'm gonna be talking about the node port. I'm gonna be talking about the load balancer. This cluster IP will be talked about tomorrow. Okay, as simple as that. And node port in the sense you will be able to access these machines. Again, they are connected. First of all, what is the use of the service? Service first of all creates set of these ports, right, based on the labels. So it has created that. Once they're in the group, then you will be able to access them using the port directly. And the second thing is the load balancer, because what is the downside of accessing them directly using the port? Pretty simple stuff. If you are accessing something using the port, that simply means you will have to specify the port number over there, you will have to specify the IP address over there, and once all these things are getting exposed, then it's not really a good thing. But this can be done as well. It is not used production wise, but it's good to know that load balancer is something that will be used. So we will be even talking about this. By the way, let's have a theory stuff here. Cluster IP exposes the service on an internal IP in the cluster. This is the default service type. The service is only accessible within the cluster. What does that mean? The thing is that by default, what happens that the pod, these are kind of connected, that is okay, but the pod, ultimately the container running inside this particular pod will not be able to talk to this node's container or this node's container. So ultimately they are separate. The nodes are somehow grouped because based on the labels, but that does not mean even whenever you get a request to this one, it will be able to forward the request to this or to this. But here the container, any app running inside the container, that cannot talk to this one or to this one, because there is no internal networking among them. And what will this cluster IP do? Cluster IP will be responsible for creating some kind of internal connectivity among them, so that they can just simply talk to each other when that is needed. When you want to run your front end here, your back end here, and by the way, even if you are running your front end here, back end here, that's okay, they are gonna be managed. But if you want to run your database here as well, so your backend needs to talk to the database. But as long as there is no connectivity, internal network, backend cannot directly talk to the database, right? As simple as that. It cannot really directly connect to the database. Backend needs to connect to the database, and in that case you need to have the internal connectivity. Okay, I hope it does make sense. Coming back to this one, as for this cluster IP and all, we will be talking about it tomorrow. Let's talk about this node port. Node port exposes the service on each node's IP at a static port, the node port. Ultimately what it does, service on a node exposes the service on each node's IP. What it means, you need to know the IP address of this port, you need to know the IP of this, and as well as this. By the way, services that has combined all of them, that is great, but you need to know the IP address because it will be exposing that on some port. So what happens, by default your Postgres is running on port 5432. Now what will you do, you will expose this to suppose 30,007. Usually the range is from 37 to some 30,000 to some around 30,000 only. So you can just have the ports like this. So what will happen, this particular Postgres that you have running here inside the container. So this particular Postgres will be exposed to this particular, let me just have it here. Okay, never mind. So this particular Postgres container will be exposed to port 30,007, and now this is exposed to what? This is exposed on this particular pod. So there was a container. Inside the container, this there was an image running on 5432 port, and from the container you exposed the result. You expose the container's result to port 3007. That simply means if you know the IP address of this particular node, you can just make a request to port 3007 and you will be getting the result of the container. It's very simple. Inside the pod there is a container, and the container is running Postgres on port 5432, but you cannot access the container. I mean, you cannot access it directly because there's no way. So what will you do? You will expose this result 5432 to something on the pod, and you are exposing it on 3700, around 30,000 port. You will be exposing it, and once you have exposed it here, so what will happen? You will, if you know the ID node, ultimately IP address of the node, then as it has been exposed to port 3000, and if you know the IP address of the node, you will be able to make a request to this one, and it will be handled. But not only that, once you create this node port, the same thing will happen here. If there's any app running, it will be exposed to port 30,007 here, 30,007 here as well. So this is how it's going to be going on, and this way node port works. So node port exposes the service on each node's IP, the IP of this node, the IP of this node, the IP of this node, at a static port. That could be that is around 30,000 and all. A cluster IP service to which node port service routes is automatically created. A cluster IP service to which the node port service routes is automatically created. You can contact the node port service from outside the cluster by requesting node port IP and node port port. A cluster's IP service to which the node port service routes is automatically created. That simply means that as soon as you create the service, you specify the node port. So what happens? This particular port will automatically be referencing this connection, this reference to this particular 5432 port of the container, of the process running inside the container, will be automatically created. And then you can directly talk to this particular port. In turn, you will be getting the response from this one. And then there is something called load balancer. Let's have a theory stuff. Let's go through the theory stuff of the load balancer. Then we will be seeing all these things in action. Load balancer exposes the service externally using a cloud provider's load balancer, node port and cluster IP services to which the external load balancer routes are automatically created. What happens? Node port, using the node port, you will be directly able to send the request here. And what is load balancer? There is nothing wrong with node port. I mean, it is really good. You are actually able to send the requests over here. But the thing is that when you talk about node port, so ultimately you are exposing the IP and you are exposing the port number, right? You are exposing these things, and it's not quite readable as well. It's not even usable. You will write the IP address colon the port number, and that to 30,000 and some around that. Okay, so on the basis of node port, we are gonna be creating load balancer. What does this load balancer do? So you will make a request to the load balancer. Load balancer will be responsible for sending the request to this particular node port. Will still be used. The container running inside the pod and the process running inside the container on 5432, this will still be exposed to port 3007 on node. And what will happen? You will send a request to the load balancer. And what will load balancer do? Load balancer will be sending the request to the node port and the IP address, of course. And then node port will be just simply getting the data from that particular container and all. Ultimately, this is just the node port. So it will be load balancer will be sending the request to the IP plus port. So node IP colon node port. So from there the request is gonna be coming to this. And once the request comes to this, then what will happen? from here actually that particular request will go to that particular container, you will be getting the result and all. So this is the safer way. This way you will just simply expose the load balancer. And what is the another benefits? Once you are using the load balancers, you can add the certificates, you can make sure that you are actually sending the request on HTTPS. So is going to be used now. I actually need to know more about SSL, but it is the extra layer of security. So once you add SSL to HTTPS, it becomes more secure. That simply means your HTTP request needs to be certified that yeah, this is the real HTTPS request, and then that you will be sending the what will actually do. I'm gonna be sending HTTPS request. You can directly send the, once you have created the load balancer, you will get the DNS name. Okay, and once you get the DNS, you can directly make a request to the DNS. The request will go to this node port and IP, and then from the container you will be getting the result. And what we will be doing at the end, first of all, we will make an HTTPS request. To what? We will make the HTTP request to HTTPS request. We will add the certificates. So the request will go to the load balancer. Load balancer will get the request on port 80. From load balancer, the request will be even over here. We will be making sure that we have the proper certificates here to just simply send a request. Okay, all these things are gonna be done on AWS. Don't worry about that. And once all these things are done, then from load balancer, the request is gonna be coming to node IP and node port. How does the load balancer know that I have to send the request over here? We will be specifying it over there. So as soon as I create this particular load balancer service, it automatically creates this port and connects this containers port to this particular port. So all these things, port mapping is automatically done. Don't worry about this. So as soon as we create this particular service, first of all, we will be focusing on this node port service. There are three types of services. Node port service. So we are gonna be focusing on this particular service, exactly how it's done. Then we will create load balancer. Load balancer will automatically create the node port as well as connect it to map the ports from this to the, from this to this, and everything will be done automatically. Then you have to just simply send a request to the load balancer. Load balancer will be handling everything. So overall, this is what actually happens. Now let's talk about load balancer as well. Once that is done, the theory part of course, then we'll do it in action. So load balancer exposes the service externally. What happens? Exposes the service externally using cloud provider's load balancer. That cloud provider can be anything. That cloud provider can be AWS, DigitalOcean, Azure, can be anything. And what it does, exposes the service externally using this load balancer. Again, this is nothing but a service. This load balancer service is provided by some cloud provider. It's not like you can just, so any cloud provider you have, that must have this load balancer service, so that you can just simply expose the things externally. Ultimately you will get a URL from here, DNS name, and once you get that, you can just simply expose it externally. Node port and cluster services. Node port, this particular node port and cluster IP services to which the external load balancer routes are automatically created. So ultimately this node port that we are talking about, that it gets mapped to this one, it is automatically created. Even the cluster IPs that we talked here earlier, that it is mainly used for making the internal connection, internal network among them, that automatically gets done. We are not going to be talking about this. We will be talking about it tomorrow. But ultimately, this, as soon as you create this load balancer service, all these things are automatically done. You have to just simply send a request and the job is done. By the way, let's talk about this. Let's talk like how we can actually create a service. We are going to be creating node port service over here. So we have talked about this here a lot. Right now we are going to be talking about the service stuff. So even this thing we have to do. Let me do it really quick. And let me exactly tell you what it does and all, and then I'm gonna be talking about the services, right? Because if we are actually starting any EKS, Elastic, let me have the full form over here. Elastic Kubernetes service. Okay, so what it does, this is the service provided by AWS that simply gives you a Kubernetes machine on AWS, Kubernetes cluster on AWS, as simple as that. And the thing is that usually you have three things. You have your mainly two things. You have your control plane, master node, and you have your worker nodes. And here, once you actually create it on AWS, your control plane master node is automatically handled by AWS. You don't need to worry about that. You will be getting your worker nodes. In worker nodes, do whatever you want to do. I hope it does make sense. By the way, if you actually want to go with this, you need to have these three things. You need to have AWS CLI, so just install this. You need to have a kubectl, you need to install this. You need to have EKS CTL, so EKS cutter, EKS CTL, let's name it like this. So you need to have these three. Okay, what is the use of these three? First of all, you need to have AWS CLI. Why? So that you can connect your terminal to the AWS. As simple as that. You will have to just simply configure some of the things, but you need to have these CLI so that you can connect your terminal to the AWS. Why do you need AKS CTL? EKS CTL, this command line is mainly used for creating the cluster. As I said, you cannot use kind when working with any Kubernetes machine hosted like online. So at that time, either you create the machine on your own, or you just simply use this EKS CTL command line and it will be created automatically. How you create the cluster using this? It's done like this. Even on DigitalOcean, you don't need to even do that. Click on create machine, it will automatically be created. On AWS, you have to configure more things. And if you want to create the machine, so EKS CTL create cluster will be created. Name of the cluster should be this, region should be this, node group should be this, and node type should be this, and ultimately which T3 small I'm gonna be using here. And how many nodes you want? I want 2 nodes, so 2 nodes should be this. Are we gonna be running this command? No. Why? Because who will write this command over and over? There are two ways. Either you run this naked command, as simple as that, and it will be working. But if you run this command, so you will have to manually write it over and over. So what we'll do, we'll actually create an ML file. Inside that ML file, YML file, and we will configure everything like this we want, and then we will run that. So what will happen? Everything will be saved, and we will not have to write the same things again and again. Having said that, you can run it, you will see it, you will get the result. But before even that, you need to make sure that you have AWS CLI. You need to make sure that AWS CLI is configured in the sense it is connected to the AWS. For that thing, what will you have to do? I will show you the way. Then you need to have kubectl. What is the kubectl? Once your cluster is created using kubectl, you will be just simply working with that. EKS CTL, it is mainly responsible for creating the cluster on the cloud. Okay, suppose you have installed AWS CLI, then what will you have to do? The next thing is that you will have to make sure that your terminal is connected. So right now, AWS CLI, AWS. Okay, if you write AWS over here, so I'm getting this AWS version. So ultimately, I do have AWS on my machine. You can install it and you will have it too. What is the next thing that we have to do? If you run AWS configure, okay, so you will be getting an option to enter your key and access key and access secret key. So if you just simply AWS CLI configuration, if you just search this, I will not then if I just simply click on this configure AWS CLI, and over here configuration setting, and hopefully I'm gonna be getting what I want. Yeah, so as soon as here it is, using namespace profile, not this, set and view configuration settings using commands. So if you run this command to quickly set and view your credentials, region, output, and format the following examples. So first of all, you will have to configure it. Why it's needed? It is needed so that you can directly talk to send the request to your AWS. How will you configure it? So first of all, you need to have AWS installed. Once you have AWS installed, you even have to configure it. So you have to just run AWS configure, and then here you have to provide your access key. Here you have to provide access secret as well. Then the region that you are using, you are on, and the format. By default, you can just simply set them to null, and it's gonna be working. But these two things you definitely need to provide. Why do you need to provide them? So that your terminal is actually connected to AWS. Then what will happen because of this? And if once you run this command, so what will happen? Inside this .aws, here I have this .aws. If you go to see .aws here, so you have what inside this? inside this you have your credentials. So here in the configuration, so whatever you save it there, all the things are gonna be saved here as well. So now you can just do it, you can configure it and see exactly what you get over here and all. So ultimately, once your terminal is connected to the AWS using the key, access key and secret, so at that time you will be seeing the stuff here as well. And once it is done, then you can just simply know more, like you can get the status and all, AWS configure list, you will be getting the keys and all, and you will be getting many more things. Even you can run AWS login and then you will be prompted to login. So by the way, this is also one of the things. So setting new configuration and create credentials command example. You can even run this command and it will be asking you things one by one, like enter the AWS region, and then it will be just simply giving you some kind of user interface. From there you have to allow. So there are many ways, either write AWS login or configure it manually, do whatever suits you best, or take the help of AI, and this way you can just simply, the end goal is that your terminal should be connected to the AWS, doesn't matter how. Do it using configuring the stuff, do it using login, so no error, blah blah blah, select this, waiting for login. So ultimately you will get a kind of pop-up box, the session will expire. Yeah, so this way you will be even logged in, and hopefully this, I haven't tried this, let me see it, what it does. AWS login, and here record a configuration profile default is already configured with access key and credentials. You may run AWS login profile, new profile name to create profile with a specified name, otherwise you must first manually remove the existing credentials from default. So the thing is that I already have credentials inside the .aws folder, and because of that thing it is just simply saying that everything is already done, so don't do it again. But if it's not done, it would be not giving me the errors and all. But okay, we can't really do anything, we have already figured the things out. Otherwise I will have to enter the ID and password again. Let me not do that. But now the question comes, how you will be getting the credentials. So you have to just simply go to AWS, duplicate this, click on this, and simply search I am here, click on this, and once you clicked on this, you have to just simply create a role, sorry, user. So click on users. Once you clicked on the user, this is the user I have created, you can click on create a user, that user will be created. Inside this user, click on security credentials, and here you have to click on access key. Over here I already have access key created. You can click on create access key. Then what will you be getting? You will be getting two things. First of all, you will be getting the key, you will be getting the secret. From here you will get access key and secret. And the another thing is that if you actually want to be able to create the EKS, I mean Kubernetes machines and all, in that case you will have to give it some permissions. You can add some permissions here. So if you click on add, so you can add the permissions. What all the permissions have I added? Amazon EC2 full access, Amazon EKS cluster policy, all these things you can just have a look exactly how many things have I added. And Amazon EKS full access, Amazon EKS cluster policy, EKS service policy, EKS worker node policy, S3 full access, scaling. By the way, these things are not needed. S3 and scaling I added it for my own use. AWS cloud formation full access, EKS full access custom, this one I created. And I am full access. By the way, this is the service that I actually created on my own. So if you don't know how it's created, okay, for you I'm showing you a better way. Okay, because if you go with this, it's gonna be quite a lot if you actually don't know anything. So you can do one thing. If you click on add permission, if you go ahead and click on attach policy, you can add something called administrator access, administrator. Yeah, so this is the one that you have to select, this one. And once you select this one, others are gonna be selected automatically. Like you don't really need to worry about others at all. So let me just select this. Let me just, for the showing purpose, that you have to just simply select this one, and it will actually allow everything. Like then you don't really need to worry about it. It's better to select the services manually, but you can just add this much and click on next. Add permission. The permission is going to be added. So this permission is here. Let me delete others from here, and let's see what's gonna happen. So this particular user, let me remove these permissions. So remove them from here. So I have removed all the permissions, I have only one of them, but it's better to have the previous ones that I had. If you actually wanna have a list of them exactly how many I had earlier. So I had these permissions: cloud formation full access, IAM full access, Amazon EC2 full access, all the full accesses. And then I created one more. I created EKS full access, EKS full access custom. So this is the one that I created. What was the use of this? It was what, giving me EKS full access. Okay, let me even show you how I created this. You can even create it on your own. So coming back to this one. By the way, this one I had, it will be doing the job. If you have only this much, this will allow you to do everything, because this is the administrative access. That simply means you can access anything. But if you come here inside policies, if you want to create a custom policy on your own, because if I try to get EKS full, so I get this EKS full access custom, and this was the one that I created on my own. And if you actually have a look at the I'll click on edit, policy editor, and this is how I actually allowed everything. I actually got it from AWS, from ChatGPT. So I'm just simply saying that action is gonna be EKS everything, resources are gonna be everything. So I'm actually allowing everything. If you click on visual, so EKS, if you click on here, everything actually allowed here. All EKS actions are selected, and then all resources are selected as well. This is just for the merging it somehow so that it works. That's it, nothing else. So you can create your custom policy on your own as well. If you get stuck, take the help of ChatGPT and all. Create the custom policy that does not exist. I have created it. But if you are using this directly, if you are using this administrator access, it will hopefully allow you to do anything. Okay, so you don't really need to worry about it. Okay, and if you want to do everything manually, so I have already told you that you can do this. If I come back here, add a permission, you can, from here you can just simply add the permissions. EKS full, let me just copy the name of this, copy it, and I'm gonna be pasting it here in my notes as well, so that in future if I get stuck, I can come back here and I can create it again. What am I doing? Just a minute, give me a second. EKS full access custom, EKS full access custom. This is the name. So that's the same name, right? EKS full access. Let me remove it from here then. So this is the name. And what is the configuration for this? Let me have the code here. Well, that doesn't really work. Never mind. I'm gonna be having the code over here and what's connected. Hello. I don't know. Just a while ago, I faced the network issue for some reason, but okay, never mind. Okay, coming back to this one. So let me copy the JSON format. This is the one that I had here for this configuration. Again, it's better to just simply keep it in mind so that in future if I need it, I'm gonna be using it from here. Okay, this is how I'm gonna be going ahead. This was the custom access that I created. And if you don't wanna do and you don't wanna go through all these things, pretty simple step. Just simply add this policy, cancel it from here. Just simply add this policy, administrator access. It will do the job. Okay, once you have this, then you don't really need to worry about it. Cancel everything. Once everything is cancelled, then the job is done. And once you have configured everything, exit it from here actually. Once you have actually configured everything, then from here you will be able to create the EKS machine. Okay, let's try to do that. How we are gonna be creating the EKS machine? For that thing, that's a simple command. Again, either you run this command directly from here, the EKS machine will be created on AWS, ultimately cluster will be created, or you just create a proper configuration file. So EKS full access custom, I added this thing yesterday. Never expected myself to be this cautious. I thought I did not add this, but I did add this. Interesting stuff, quite smart. Sorry, what did I change? Yeah, this much is done. And this is the configuration for this cluster.ml. Let me copy it from here and exactly show what it does. So ls, I already have clusters.ml here. I'm gonna be creating EKS cluster.ml file here, and well, vi EKS cluster.ml. Let me paste everything over here, and let me tell you exactly what all configuration I have. It's pretty simple. As usual, this is gonna be cluster config. I got it from AWS side. So ultimately, even if you ask ChatGPT that give me configuration for creating a cluster, it will give you copy paste what else, but you should be able to understand. Okay, API version. Okay, this is the API version. Cluster kind cluster metadata. What should be the name of my cluster? The name of my cluster. Let me make it my cluster, or better EKS cluster. Okay, so this is the name of the cluster. The region is API South. Version is this. Auto mode config enabled false. By later in the future, by the way, right now this auto mode config is enabled, I mean false by default. In future it will be I mean true. That simply means it will be enabled, and if it is enabled, you have to configure more things, and many things you will have to add from your own side. And if it is disabled, then many things are done automatically. So if I'm keeping it right now, it is not needed. You can even remove it from here. It is for the future EKS-CTL versions. So in future, this is gonna be true by default, so it's better to just simply have it false. I just came to know from the ChatGPT side that okay, I was even getting the error, not error, some kind of message that in future this will be enabled to true. So it's better to keep it false. Keep this thing that in future you will have to set it to false. So I said okay, let's set it to false right now. Then there is something called with OIDC. Again, when I ran the command for the first time, I was getting this message that OIDC is not enabled, and because of this thing, few like this VPC CNI was not getting installed. So I just enabled it here. Again, if you remove it, will something happen? Nothing will happen. Remove them. Your choice. Coming back to this one, some add-ons that are needed added over here. What are the add-ons? When you create a cluster machine, ultimately Kubernetes machine, it needs to install a lot of things, and one of those things is VPS CNI, and attach policy is gonna be this, and this is what it's gonna be just simply attaching. How do I know this? Simple, ChatGPT. What else? Again, even if you just remove all these things, that's not gonna make any difference. So if you want, you can just remove it. Even without this, it will work. The important thing is here, manage the node groups. You wanna create a node groups, right? What is the use of that node group? That node group will be managing the nodes, as simple as that. Your node worker will be created by control plane, will be created by AWS side. You will only get your nodes, and then you will have to give the name of the node group. You will have to specify that what should be the instance type, T3 small, desired capacity, how many of machines, how many nodes I wanted, 2, minimum size 1, maximum size 3, and that's it. This is how it just simply goes on. Again, I made AI write this thing for me. Okay, so it's not like I have written it on my own. The thing is that you should be able to understand what it does, and slowly as you keep working on this, you will be able to understand it even better. Okay, let me save it from here. And if you actually have a look over here, if I go to my notes, and if I actually show you this, initially I had this command. Wasn't I doing the same thing? EKCTL create cluster, name should be my cluster, region should be this, node group should be my nodes. It's gonna be creating a group. Type 3 small, node 2, I just want 2. So ultimately it does the same thing, right? But here, once you specify everything in the ML file, so everything is actually configured properly, and later in the future you can just simply use it, just copy and paste, or just simply run the same command, it will be used. By the way, now what do you want? You want to create a cluster on AWS. Simply run this command, and make sure that you have to only run this command when you have AWS CLI configured, kubectl installed on your machine, EKSCTL installed, and AWS is configured. So just run this command, it will be configured. You will have to enter your key, access key, and secret and all. And once all these things are done, then just simply run this particular command. Where is that? EKS create cluster, and a file name is gonna be cluster ML, and that's gonna be created. So let's do that. By the way, in our case, the file name is EKS cluster ML, so I'm gonna be just simply using this. So EKS, again I have EKSCTL, so if you run this here, so I do have this EKSCTL, you will have to install it again. So EKSCTL create, what do I want to create? I want to create a cluster. What is the file name? The file name is EKS cluster.ml. Let's simply run this. Loading config EKS cluster error, YAML to JSON ML line could not find this. There is something wrong with this, so let's simply figure it out exactly what have I missed here. Cluster ML, and well, this thing is not supposed to be here. Once this is done, let me run it one more time, and this time what will happen, let's have a look here what it is started doing. EKCTL version this using region AP South 1, setting availability zones. It is just simply setting these availability zones. Lots of things are just done by AWS by itself. Does it mean that you can create it from this cluster, I mean terminal side only? No, you can directly create the Kubernetes machine. I will even be showing you that how you can directly create the machine from AWS. But the good thing of this is that you have to configure, you have to write the command once, run the command, and that will be creating. And if you are creating manually clicking on the buttons, then you will have to go through the same process again and again, right? I hope it does make sense. So what it is doing, setting availability zones. So these are the subnets that are selected. Node group is this, will be using this, using Kubernetes version, creating EKS cluster. So ultimately it is just simply creating this stuff. You can read more through it, and this is how it's gonna be just simply getting it done. Having said that, it takes time. It takes around 10 minutes or something, probably around 10 minutes, 5 to 10 minutes at least. So it's gonna be taking some time, and then it's gonna this cluster is going to be created. Once the cluster is created, then we will start working with that, as simple as that. But before that, let's come back here, and it will just keep working in the background. And once all the things are done, by the way, kubectl delete svc service name, svc service name, let's keep it inside service edge. Okay, this thing is done, and let me add it here. Let me collapse it right now. So ultimately, whatever we had to do related to AKS, Elastic Kubernetes Service, we have already done with that. Let's talk about services. So we were here talking about the services, then I started creating the Kubernetes machine because that was needed. That is getting created in the background. So once that is created, we will just simply do the same thing over there as well. But before that, now let's talk about the services. So we had three types of services. We have load balancers, we have node port, we have a cluster IP. We know that what is the use of node port. Once we create this service, this automatically does mapping, maps the ports. So on your node, you will have some port. That port will be mapped to this containers port automatically. And once that is done, so once you have the IP of your container, you will and the port, you will directly be able to talk to this Postgres app, as simple as that. Apart from this particular thing, there is something called load balancer. So load balancer works on top of node port only. So when you create load balancer policy, so ultimately a load balancer is created. Again, this is load balancer service is provided by that particular cloud provider, and once that is created, so the load balancer sends the request. A load balancer already knows the IP address, ultimately, yeah, kind of IP address and the port number. It sends the request there and the job is done. I hope it does make sense. Okay, let's talk about this node port service, how we are going to be creating this node port service. I will be telling you about everything, exactly what it does and how it does and all. So by the way, this thing is working in the background. Let it work. Coming back to this one, service.ml, this is the first service that we have over here, and that is mainly when it comes to service. So we have different types of services. The first type is the node port. So TH3 actually, node port service. This is the service that we have inside this, or it's quite small actually. Turn into अरे नहीं भाई ऐसे भी नहीं करना था. Turn into H2. Yeah, this is how this is enough, and I'm gonna be having, let me give it some color as well. Ta-da-da. This one should be fine. Okay, coming back to this, or even to be precise, I wanna give it this color. Okay, so this is the service that I have. So let me select this all. I will be talking about everything. So let me sorry, this is not what I want. I want to select this as well. Yeah, now it's fine, just like this. Let me keep it here. Similarly, let me keep it here as well. One by one, let's keep everything on top of, I mean, one after the other. Okay, so these are the things that we have done. So first of all, we are talking about this node port service, and this is the service ML. The name can be anything, don't worry about that. Ultimately, you have to configure everything. What we are saying, we are just simply saying that, let me copy it from here. Okay, whatever we are saying, let me create let it work in the background, ls, and I'm gonna be creating vi node port service.ml. This is a service ml file that I'm creating. Paste everything here and let's see what it says. So first of all, the version 1. What I want to create, I want to create a service. What is the metadata? What is the name of the service? The name of the service is the Nginx service. That's fine. Okay, after that, what is the selector? The name is app Nginx. On the basis of this, why we need to do it? When we are creating a service, what the service does? Service is responsible for creating set of nodes. How will it create set of nodes? It will be creating set of nodes based on the label. So it will first of all find the same nodes having the same, like find the nodes having the same label, and then it will kind of create a group of them. They are gonna be connected, and whenever a request comes to one of the nodes, the request might get forwarded to the another as well if that's busy doing something or the other. So I mean, this forwarding things is quite common here. So kind of load balancing happens here. Okay, coming back to this one. So in this particular section, so the selector is app Nginx. That simply means this service that I'm creating here, this service will be selecting the pods based on this particular label. So if there is any pod having this label, that pod will be under this category. As simple as that. Okay, apart from this particular thing, we have protocol. What is the protocol? Protocol is TCP. Usually protocol should be HTTP. Because if I set the protocol TCP, so TCP protocol should be there. Let me take the help of AI here. I'm not satisfied with this. How about setting the protocol to HTTP? Because at the end I would have to do that directly on AWS load balancer. So why not do it here? Is this okay? Just like this. Let me check this thing out. Yes, your ML file is mostly correct, but let's review it carefully. You don't face issues later. Version is this. Port number is this. Type is this. Things double check. Pod labels must match. Yeah, that's right. Node port range, you used 3001. Good, it's inside a valid range. 30,000 to 32. This is the valid range for that. So the range for the node port. So let me just simply have it here as well. This is the range actually. So node port range is this actually. That's fine. Under bit like inside this range only the number the port should be. And coming back to this. Accessing the service, kubectl this, node this, type load balancer. These things are fine. HTTP, if TCP goes to TCP, that's fine. What should be the protocol, TCP or HTTP? Good question, confusion. The short answer, Kubernetes service, you should use protocol TCP even if you HTTP or HTTPS. Why TCP and not HTTPS? Kubernetes service works at layer transport layer, not layer 7. So TCP handles raw traffic, HTTP and HTTPS WebSockets, everything runs on TCP. So HTTP not supported in so Kubernetes doesn't care if HTTP this WebSocket, all of them run on TCP. When does HTTP matter? HTTP comes in play when you use ingress layer 7 routing / API backend, this load balancer. There you can specify HTTPS and all. So final answer, keep this in a load balancer. I get a TCP because I mentioned it here. So that means I should convert that to HTTP. You are very close. Just one more. Changing to protocol TCP to HTTP in service will not work because Kubernetes service only supports this. It does not include this. Okay, fine. So load balancer shows TCP. When you use it, TCP, Kubernetes tells create load balancer that forwards to TCP. AWS creates a TCP listener. What you actually want HTTP, so you have to correct approaches. Load balancer port this protocol TCP. Result will be AWS load balancer listens on TCP, works for HTTP automatically. This is normal and correct. Option 2, use ingress, best way for HTTP and HTTPS if you want to domain this. Look, I don't know about ingress. I still take 2 days more to know more about it. So what will I be doing? I will be doing this listening stuff manually. Like I will be changing a few things on the load balancer side. I will show you exactly what I do. Okay, and then once I learn this ingress thing and all, then I will be able to do this stuff on my own as well. Okay, by the way, coming back to this one, let this thing be same here. By the way, Kubernetes mostly works with TCP, so I'm not gonna be changing it. Port, what should be the port? Port is 80. What is the target port? Target port in the sense the target machine that is actually running. What is the port for that? And the port for that is, in our case, is 80. Are we running Node.js? Sorry, we are running Nginx, right? It will be running on port 80. Okay, how about the explanation part that is explained here? Yeah, so port and target port. Let me know more about this. Valid range 30,000. Node port in the sense, this is gonna be the node port. So ultimately, this port I'm talking about. So the port of the node, and that port will be mapped to this particular container port. So that's fine. The thing that I have to know, the target port is gonna be this. So here, if I have Postgres running, so target port is gonna be 5432, and node port is gonna be 30,007, and I have port. So I have to know the difference between them. And port and target port difference, explain everything. Great, this is very important concept in Kubernetes. Let's break it down. So port and target port, these two are not the same thing even if the values match. Simple. Port is gonna be port of the service, target port of the container port. Okay, simple. Understood. So user service pod container. So user sensor service pod container. Okay, that's fine. Understood. So ultimately, this is the port of the service, as simple as that. So the protocol will be used TCP. The port of the service, that is 80. The target port is gonna be 80 of the target container, and if the Postgres is running, this should be 5432. And node port is gonna be 30,007. That's okay. This can be anywhere between the port range, within the port range, and the type is the node port. So ultimately, this is what I'm doing. So what will happen? A service will be created. As soon as a service, let me save it first of all. Cat node port. So once I run this, so what will happen? A service will be created. Once a service is created, then what will happen? Once a service is created, so I will have a node port on all the machines. So on all these machines, that's gonna be node port 30,007, 30,007, and 30,007. That particular node port will be mapped to port 80 of the container. So the port that I have, it will automatically be mapped to port 80. So if I have Nginx running over here, so I will have port 80 here. So Nginx. So it will automatically be mapped to port 80 here. So this is how it's gonna be working on. And once this much is done, this will be happening on all the nodes that are grouped together. How will it be grouping? It will be grouping based on the labels it has. Okay, so it will be grouping all of them. So if I just simply run this, in case if I just simply run this, then what will happen? Restart the cluster with a few extra ports exposed, create a kind.ml. Yeah, interesting. I will be talking about this. But by the way, should I run it or not? Okay. Let me see if I'm missing something or this is fine. First of all, we are creating a service. What will this service do? This service will just simply set the group, like create the group of them. They are gonna be grouped together, and once they are grouped together, it will be creating a node port, and this node port will be mapped to the Nginx image. It's gonna be only doing this much. Now once this is done, but there is only one problem as well. And what is the problem? If I know now at this level, if I know the IP address of what? IP address of this particular node, then I can directly talk to this. First of all, let me create the service, and then I will talk about anything else, otherwise it's gonna be even confusing. So how do I create a service? That is something I have to worry about. And kubectl apply this, not this. Let me have a look in my notes if I have anything. So for creating a service, kubectl get pods, oh why not really this. Okay, kubectl apply service.ml, you can just simply apply it. Well, didn't know that, it's that simple. Okay, coming back to this one, k apply f, what is the name, node port service, applied. Wait for a while, it's created. So if I say k get svc stands for services, so I'm gonna be getting one more service over here. I have nginx service node port, this is the cluster IP, let's not worry about that. And cluster IP is something we will be talking about tomorrow. And it is saying what, inside the container the main app is running on port 80, that is exposed to port 30,007 on the node. So on the node over here it has been exposed to port 30,007. Now the question is it has been exposed to this. So if I had this machine on Kubernetes, on AWS or something, so I definitely had the IP address of this port as well, so I could have talked to it directly. But right now, as I have it on my machine, local machine, how am I able to talk to this? So somehow what am I doing? The container that I have, I am exposing this container to this. Somehow I have to expose it to my local machine. Again, this is completely optional, you can just stop it right here, you can deploy it and you can get the IP address and you can just simply go ahead. But if I want to use this, like get the result in my local device, I will have to configure things a bit more. So cluster this, control plane, extra port mappings, container port number this, host port number this. So this is the lovely that's crazy. So what is happening here is pretty simple. Look, suppose I deployed this whole Kubernetes cluster is deployed on AWS. What would happen? I would get the IP address of this container, this node. I would get the IP address of this node. I would get the IP address of this node, as they are connected as well. Kind of if I send the request to this, if it is busy, the request will go to this or this. Why? Because they are kind of grouped together with the help of the labels, so it will be forwarded. And not only that, apart from this particular thing, if I have the IP address of this, I can directly send a request to this particular node, as I already know this is the port. So to this particular port the request will be sent, and from this particular port, as it is already mapped to the container, I will be getting the response and the job will be done. When I'm actually running all these things on a Kubernetes cluster. Okay, but if I'm running it locally, in that case what am I supposed to be doing? By the way, there is a problem. There are many problems, not only one problem. The thing is that I have started my Kubernetes machine has been created, right? So right now if you actually have a look over here, so EKS cluster that I wanted, that has been created. That simply means if you go to AWS here and if you search here, come on, EKS Elastic Kubernetes Service. So over here inside the cluster, this is the cluster that has automatically been created 18 minutes back ago. That simply means we were the ones who created 18 minutes ago, right? So it got created automatically here. That's great. How it got created, we ran everything, you must have seen that. So it got automatically created over here. That's fine. That simply means if I run k get nodes, what will happen? I am getting these nodes. Really important thing to have a look over here. IP 192 did this. These are not the nodes of the kind. This is not the nodes of the container. I mean cluster created by the kind. These are the nodes provided by EKS, Amazon Elastic. Elastic Kubernetes service. So ultimately, right now the cluster got created, and as this cluster got created on AWS, I am already connected to AWS. So whenever I write probably nodes, so I'm gonna be getting the nodes that are that belongs to that particular Kubernetes machine that is on my AWS machine. Okay, so I hope it does make sense, because it got created. Otherwise I would be getting my default nodes. Right now I'm not getting my default node because I'm connected to AWS machine. That is the problem right here. But okay, as I'm connected, so what was the issue here? The issue was simple, that right now the problem, somehow I wanted to expose it to what? Somehow I wanted to expose this particular ultimately port number to my local device. Right now it is not exposed to my local device, but somehow I wanted to do that. So how would I do that? I cannot really do it right now because right now cluster is running on AWS. So as that is already running on AWS, it's better continue with the flow because I don't want to stop that. It would take a lot of time. I will definitely get it done on my local machine as well. The thing is simple. On AWS we don't need to worry about it because we will directly get the IP address of it. On local machine we will have to configure a little bit more so that this node that I have, this gets exposed to maybe this cluster directly, and once this is exposed to this particular cluster, I can send a request to this cluster, and then in turn I will be talking about this. I mean, something or the other should be done. Again, how it will be done, we'll be talking about it, but let's directly jump into this particular stuff. The machine has been created on AWS. We are even able to see EKS cluster has been created. If I click on this 5 upgrades, let's not worry about this. Resources, if you actually have a look at this, so there's nothing, no pods, nothing at all. Compute, there's no compute, nothing is actually running. Add-ons, these are the add-ons that has been added. Even if you have a look, Amazon VPC CNI, we specified over here. Okay, you can know more about it. Even I'm not that much aware of all these things. This is the first time learning about all these things, but yeah, it seems like things are actually connected, things are working, everything is working as expected. Okay, what is the next thing that we can do? The next thing that we can do, it's pretty simple. Let me exit it. The machine has already been created. If I say k get pods, I don't have any pod. K get nodes, I have 2 nodes because in the configuration I created 2 nodes. It takes some time because it needs to make a request to the AWS and then get the response back. So definitely it's okay, it did not take that much time, but yeah, this is how I'm just gonna be getting everything. K get, apart from this particular thing, what? K get, if I try to get replica set, I don't have replica sets. So let me do one thing. Let me directly create deployment, and once I create the deployment, so what will the deployment do? Pretty simple stuff. When you create a deployment, so deployment create replica sets. Replica sets in turn creates pods. Pods create what? Pods create your containers, and containers run the image that you have specified. As simple as that. Okay, as I'm connected to my AWS machine, so whatever I create here, that will be saved in my AWS machine. As simple as that. This should definitely make sense. We have a file called deployment here. So deployment.ml, this is the file we have. As simple as that. Good that we have this particular file. What are we gonna be doing now? As we have this file, so let me do one thing. Let me run this. So if I say k apply f deployment.ml, so what will happen? This configuration will be applied. That simply means a deployment manager will be created that will create 3 replicas. Ultimately 3 pods will be it will create a replica set that will be responsible for creating 3 replicas, 3 pods. The label should be app nginx. The template, this is the template that's gonna be going on. Ultimately nginx should be running there. Interesting stuff. Let me just simply click on this. What happened? K get pods. 3 pods have been created, but before even that, k get deployment. The same thing that I did locally, I'm doing it now. Whatever I'm doing here, because everything is connected to the AWS machine, so that is actually happening there. AWS Kubernetes machine. So deployment. So this is the deployment that I have created, 3 by 3. All of them are running. K get and what is that? K get replica sets. So RS. So K refers to kubectl. So this is the replica set that I have. Nginx deployment and then subgibberish. And 3 desired, 3 are current, 3 are running. Ultimately everything is running. K get pods. These are the 3 pods that are running right now. Can I access them? Why? This is actually running where? On the AWS machine. Right now, I think even last time I was trying to access the pods here, I was not able to access them. So hopefully even this time it will not be accessible. Yeah, your current IAM principal doesn't have access to Kubernetes objects on this cluster. This might be due to current principal not having IAM access. Okay, the current one does not have IAM access, so I need to provide it IAM access. But what I did, if you actually go to my roles, so I have given it one role, that is administrative access, administrator access or something, and it gave me all the access, so I am able to create this. So keep that particular thing in mind. As for the pods, I am not able to get them here, but if you actually go to the EC2 machine, if you actually come here, if you search EC2 here, by the way you can directly get it from here, but let me search EC2. EC2 means your nodes got created, right? So ultimately you have nodes running, worker nodes. So definitely that simply means EC2 machine is running, because at the end those nodes are gonna be running inside the EC2 machine. And these are the two EKS cluster my nodes node, EKS cluster my nodes node. These two workers, they have been created. So these are the two workers that have been created from AKS side. And if I click on this worker, so what will happen? I have the IP address of this worker. What happened? These workers got created. And as these workers got created, so on AWS I am able to get the IP address. And once I am able to get the IP address, how about copying it from here? How about pasting it from here and over here? And how about writing 3007? What will happen? Nothing will happen. Why? Though you have created your nodes, but you will have to add one more thing, like in AWS you have to configure it manually, and on DigitalOcean and all most of the things are configured directly, but here you will have to make sure that you are actually allowing 30,000 request on 30,007 port. So what will you do? Nothing. If you actually have a look here, over here, so these are the, just a minute, these are the two instances that are running. And if you check out the security group, scroll more, this is the security group. If you have a look at the name, both the security groups are the same. That means doesn't matter you have one node or two node or 10 nodes, the security group is going to be the same. That simply means if you change the security group once, that will be changed for all. Such a good thing. So let me do one thing. I'm gonna be changing the security group. Click on this, click on the security here, or you can directly go to the security group. This is the security group that we have. And right now what it is doing, if I click on inbound rules, so it is kind of allowing all the traffic, but still we are facing the issue, right? All the traffics are allowed, but it is not able to allow 30,007 requests. So what I'm gonna say that, bro, you are gonna be getting custom TCP request on port 30,007 and make sure that it is allowed from anywhere. Let me simply save. Done. Now if you send a request to this, the IP address 30,007 hopefully should work, and it is working. So what happened? You are able to, you got the IP of the machine, whatever machine got node ultimately. So you got the IP of this particular node, and because this container Nginx was already exposed on 30,007 port, so you just simply said the IP address and the port number, and you are getting the Nginx, because the Nginx was already running inside this particular container. Nginx is already running and the job is done. As simple as that. By the way, when you send the request, if there are more, even there is a pod running inside this, there is a pod running inside this. So whenever you send the request, so if you are sending the request to this, if this is busy, the request will automatically be forwarded to this or this. So it's not like if you are using the IP address of this, so it will only handle the request. No, there is a load balancing type something happening inside this. So sometimes this will happen, sometimes this will happen, and sometimes this will happen, as they are already what set of pods, yes or no, when you created the service. So at that time all the pods having the same label, a set of pod got created using those pods, right? So whenever you get a request, kind of a load balancing happens. So ultimately service is responsible for that, but yeah, load balancing definitely happens, and I will prove it to you by showing it exactly. I am gonna be sending a request to this one, but sometimes I will be getting the response from this, sometimes from this, and sometimes from even this. Okay, so I will be even showing exactly how it works and all, but overall I hope it does make sense. So ultimately what we did, we got the IP address of this, we made a request on port 3007, we are getting the result of this nginx. Amazing job. Okay, we are getting that. What is the next thing? The next thing is that this is really bad. I mean, literally, have a look at this. You are having to type the IP and then the port number, and this way if you give it to somebody, it's gonna be really bad. But is it deployed? Yes. Are you able to get the result? Yes. Is it the best way? No. Okay, so this particular thing we have done. Okay, what is the next thing that we have to do? The next thing is that if you want, you have only one pod running right now. Probably 3 pods running right now. Let me see. You have 3 pods running right now. That simply means those 3 pods are running on different nodes. That's right. What I want that, okay, 3 pods are running, that's fine. How about running just a minute, what can I do here? Let me check this. Inside the container I have this running, right? Yeah. And what I want to run one more machine, and if I run the machine here, so ultimately 2 pods will be running inside the same. No, that's gonna be problematic here. What can I do here? I wanted to do something more here, but I forgot, and I did it like in the morning or something, not yesterday actually. If I can think of it right now, or I had a code actually, just a minute. Let me have a look at the code. Learning Kubernetes, open code. So what exactly I did back then, I just forgot that. Just a minute, give me a moment. Deployment, configuring it here inside the deployment. If I'm configuring this, so inside the same container 2 pods are gonna be running, and when 2 pods are actually running, that's gonna be problematic. Why? 2 pods are running, bro, inside the same container. Not even 2 pods, not 2 pods. Actually, inside a pod, there is a container running, and inside that particular container 2 services are running. And when 2 services are running actually, so at that time what is happening? So what happens here? Inside the container, I'm running nginx. I'm also running suppose httpd. So or maybe Mongo. How about this? Creating a pod on your own. That pod will definitely be assigned to something. Okay, let's do it. I'm gonna be doing it manually. Okay, so ultimately I will have to create a pod manually, and right now 3 pods are already running. So if I actually have a look at this, so what is happening here? Where is my main file? Is this the one? Nope, this is not the one. Kubernetes self, yeah, this belongs to me, and this one belongs to the course. Okay, let's close this. Coming back to this one, so I have done this much, and what is this doing actually? It is creating 3 pods. Okay, that's great. It is creating 3 pods. What is the next thing that I can do? The next thing is that I will be creating one more pod, but the question is, how will I be doing that? Is there any way to create one more pod here? What I want here, because I already have 3 pods running, so 3 pods are running, maybe 1 pod inside this, 1 pod inside this, 1 pod inside this. What I want, in some of the pods, another request, suppose in this particular node, here nginx is running on 80 port. I want to run suppose httpd over here. So how can I do that? First of all, pods.ml. This is the file that I have. Let me get rid of this, not really needed right now. And what I want to do that what metadata, the name of the pod, that's gonna be httpd pod. Okay, the question is how will I run it? I'll see it. The label should be the same so that it is going to belong to the same category. So that's what I wanted. Apart from this particular thing, name Nginx, not really. Name is gonna be httpd app. Image is gonna be httpd @latest. Container is gonna be let it be the same. Why I want to create one more container? Kind is gonna be pod, just like this. So I'm gonna be creating one more container having the same label, so that I have another pod running in one of these nodes, suppose inside this one, and as it has the same label, so it will be that it will belong to the same group only, same node group. And once it belongs to the same group, so and it is running inside this, so probably inside this I have Nginx running, inside this I will have HTTP running, and it will also be running on port 80. So whenever what I want, whenever I make a request, so whenever next time I will be making a request, so the request will go to this one, so I will be getting the Nginx request response. I'm gonna be getting the response of Nginx, and sometimes this request will be forwarded to this one as well, and at that time I'm gonna be getting the HTTPD request. So that's what I wanna check, that whenever I make a request, whether the request actually gets forwarded. If I'm using the IP address of this one, is the request being sent to this one only, or the request is actually sent to this one? That's what I want to check. And to check that, I have to just simply start this particular pod somehow. But the problem is that clear everything. K get pods. 3 pods I already have running, and if I start a new pod, that pod will not be implemented, because as per Docker deployment, as per this deployment, I only need 3 replicas, not Docker, I mean Kubernetes deployment. So even if I try to start like k apply and pods.ml, so file pods.ml, and if I run this, created k get pods. Oh, why is this getting created? K get pods running. Why? That's wrong. Something is missing. This should not happen. Why? Inside deployment, what is the deployment here? Postgres, not this one. Deployment, match labels Nginx, and this is the pod that I ran. Label was Nginx. Okay, let me describe that. K describe pod http dpod, and what is the group name, like label name. Inside this, the labels is app Nginx, so I have this label over here. HTTPD is running inside that, and apart from this particular thing, ls k get pods, k describe pod, and I'm gonna be describing this pod here. Let's simply enter. It also, okay, it has one more level, but it has the app Nginx. So this has app Nginx. The top one has app Nginx. So why is this allowing it? Okay, at the end, this is running inside what? This is running inside IP 192.168.182. So 182, and this one is running inside the node 26. So they are running on different nodes. Okay, why is this happening, bro? Not getting this. The thing is that as per the deployment, it should not start. How to check whether they belongs to the same? K get pods. One thing is, okay, let me do one thing. K get, I mean K delete replica set. I'm going to delete this replica set. This has been deleted. Okay, get pods. New pods are being created. This still remains the same. Other ones have completely been changed. I need to explore it even more. Otherwise, I'm not sure I will be able to do it. It's not about deployment right now. It's about how am I gonna be able to adding a pod when 3 pods are already running. If I stop the previous pods and so manifest HTTPD pod this label is this, container is this is how it's gonna be going on, and I have deployment.ml. Inside this deployment.manifest, this could be done that instead of doing this I'm gonna be doing this. Like, I have this pod right here, Kubernetes. Let me close this and let me stop everything. So k get and deployment, and what will I do? I will just simply k delete. Again, I cannot really delete directly. K get all. I'm gonna be getting the name for this deployment. This is the name for the deployment. Let me copy it from here. K get k delete, and let's simply paste it here. So ultimately deployment is going to be deleted. K get deployment. There's no deployment. K get pods. This is one pod that I have, and it has the same configuration. So let me do one thing. Copy pods.ml to http pod.ml. A new file will be created, or maybe this would be renamed. Probably. What will happen? Let's see. Run it. Yeah. New file will be created. HTTP pod I have. Interesting. And let's name it nginx pod.ml. So I have two pods here. I have HTTP pod. We have already the stuff written here. We have nginx pod. Let's name it nginx pod app nginx and nginx, just like this. It will just keep going on. Right now I have two pods. So instead of creating the deployment, I'm gonna be creating the pods manually. So k get pods. I have this pod right now. Okay, this is running. I'm gonna be creating one more. So k apply f, and that's gonna be nginx pod ml. Let's simply run this. So I have two pods running right now. K get pods. So right now I have two pods, and both of them have the same label. How can I check it? K get k describe pod http pod or k describe pod httpd pod, just like this. And when it comes to the label for this app nginx, k describe pod nginx pod. So this also has the same label. That simply means both of them, we have two pods over here, k get pods. Both of them have the same label, and as both of them have the same label, and let me even check one more thing. K describe pod, that's gonna be http pod http pod. When I'm describe pod http pod httpd pod, even the name is wrong. Not http, that should be httpd. Forget about that. Coming back to this one, it is running on which container? Which cluster? Node ultimately. 25, 26. Okay. And the another one, nginx pod. It is running where? It is running inside. Okay, this is httpd, and this Nginx is running on 89.182. So ultimately they are running on different nodes. K get nodes. These are the nodes that I have. So HTTPD running on this one, Nginx is running on this one. So we have two nodes. On these two nodes, in one of them Nginx is running, in one of them HTTPD is running, and in the other one Nginx is running. Both of them are running in two nodes and they are running on the same port. So what is happening here? Suppose let's remove this from here. So I have these two ports here, and on 30,007 Nginx is running, here 30,007 HTTPD is running. So ultimately, and they are grouped together, so they are set of nodes. So whenever I will send a request now to this one, whenever I send a request to this one, that I should be getting Nginx. But if I keep sending the request, there should be a time when the request should be forwarded to this one as well, even if I'm not sending a request to this the IP address of this one. And same thing should happen with this as well. If I'm sending the request to this particular IP address, I should be getting this response, but sometimes the request should be forwarded to this one because they are set of ports. Okay, this should definitely happen. And especially if you want to get the IP address of these, so it's pretty simple to get the IP address actually. So if you want to get the IP address, don't do anything, just directly go to AWS. Inside the EC2 machines, you will have the EC2 machines over here. So instances, here you have two EC2 machines, click on them and you will just simply get the IP address. So this is the IP address of the first machine, and similarly same thing will happen over here. So this is the IP address of the second machine. So this way you will be getting the IP address. The question is, will it actually happen? And one more thing, if you actually want to get the IP address directly from the terminal side, so from the terminal side, how will you get the IP address? So you want to get the IP address of what? K get nodes, right? So you want to get the IP address of these nodes, these two nodes that you have over here. So what will you do? Just describe them. So what I mean, describe what do you want to describe? Describe nodes. I'm going to be describing all the nodes, and once I click here, so one by one I will be getting the information about the node. Great. So if I go to the top, here, so here I ran this command describe node. This is the first node, 2526 ends with this. This is the first node, ultimately worker node I have, and here it should have something called external IP address. Isn't it the same? 13.201 3166. Come back here, AWS, and the second one, ultimately the first one, 13.201 3166. Isn't it the same IP address that is mentioned on my AWS? Yes. Scroll down, you will be getting this another one as well. So this is the another node, and let's check the IP address of this one. External IP address. Here 3.108. whatever. Come back here, select this one, 3.108. So ultimately, yeah, you can get the IP address directly from the terminal as well, or you can go to your EC2 machine and you can get the IP address from there. So congratulations, you've come quite far, and we have even deployed this stuff on EC2 machine. What is the next thing? The next thing is that what is happening right now? What is happening that I have these two nodes. Yeah, even I know the IP address of them. Even they are the set of ports. They are connected via labels, right? So service has done that. So whenever I send what should usually happen? If I'm sending a request to this one, I should be getting the result from Nginx. But at some point of time, the request should be forwarded to HTTPD, ultimately this particular node, and I should be getting the node result from this one. Usually what happens? Usually there is something called load balancing happens. This is just for the testing purpose I have done. Usually what you do, if there is a port 80, so on the port you run the same app. You run the Nginx here as well as Nginx here. So if you are sending the request here and it is busy doing something, so the request will be forwarded to this one. We are running two different applications on the same port, so that we can just simply check. So what we will do, copy the IP address. That's already copied here, and the port 3007. So let me copy the IP. This is the 13201. So coming back to this one, 30, and this is the another one. So we have two apps here. Let me paste it. 30,007. We are getting the result from Nginx. Keep refreshing the page. Hopefully we should be getting the response from HTTPD as well. We should be getting it works. Keep refreshing. What else? Don't really have any other option. Hopefully it's gonna be working. It should be working, shouldn't it? Let me check one more time. Coming back to this one, let me send requests. Oh, it does work. So ultimately, what is happening now? We are getting the result of HTTPD. It is just simply saying that it works. Keep refreshing the page, and at some point of time, you should be getting the response from Nginx as well. By the way, it will keep handling the request on its own. But sorry, remove it. At some point of time, it should be forwarded to the Nginx as well. Or let me copy the same thing here and let me paste. Sometimes things get cached as well, so let me paste it here. Yeah, great job. So what is happening? The request the load balancing is actually happening. First of all, you are getting the request was coming here, again and again, here, and suddenly the request started going here. So some kind of load balancing is happening inside this particular set of pods as well. So that's what I wanted to check. So this particular thing we have done. What is the next thing? The next thing is that we have already deployed, haven't we? Yes, we have. Even we don't have any deployment, so let me create deployment right now. This was just for the testing purpose. Usually we don't do this, rather we run the same app on the same port. But okay, this was just the deployment purpose. So what am I gonna be doing? Okay, get pods, and right now let me run only, or let it be just like this. So ultimately 2 pods are running, whether I have the deployment or not. And right now I have event services. So k get svc, k get services. So how many services do I have? I have one service that is called Nginx service node port. And this, what this service does, this service is responsible for that the application that you have running on port 80, that port will be mapped to port 30,007 on your node. So this does this thing. Right now we are gonna be creating one more service, and that will be load balancer. What will this do? It will do this only. Load balancer does the same thing. One extra thing it does, it creates load balancer for you. So if I show you the, first of all, it will always work. By the way, you can always go ahead like this. But why do we need load balancers? Because who will write this command again and again? I mean, isn't it crazy writing this? Okay, let me refresh this. Okay, here I am also getting the request from HTTP. Let me refresh the, by the way, I came somewhere else. Let's not worry about that, but it is working. Now I went back to Nginx again, and okay, nothing is happening. Nginx. Sometimes request actually, the result actually gets cached, and because of that thing, you keep getting the same thing again and again if you are requesting for the same thing. But okay, never mind. Let's come back to this one. What am I gonna be doing? Refresh it. Okay, no, nothing is happening. What am I gonna be doing right now? The next thing is that I'm gonna be creating load balancers. What have we done so far? We have actually created a proper node ports, and we even know how it works and all. The type was node port, and the node port was 30,007. The target port was 80 because we had Nginx running. The port of the service, that was 80 only. Service was listening on port 80 because service was getting the request directly. And then we have these protocols and all. So ultimately these are the things that get done here. What is the next thing that we are gonna be focusing on? You can even delete the service. So kubectl delete svc service name, and you can just simply delete it. You can get the pods, you can dismiss, you can even get the services and all. This is how we have got this particular thing done. What is the next thing? ts2. The next thing is that load load balancer. What will this do actually? It will do the kind of the same thing. Let me first of all change the color of this like this. Sorry, just suffering from sneeze a little bit. Okay, so what does this load balancer do? Load balancer does the same thing. It automatically, sets the node port. So earlier you set the node port on your own, and what will this load balancer do? It will set the node port from your own side. One extra thing that load balancer does, it creates load balancers. Okay, so if I come back here, so when you create a service called load balancer, it will do the same thing. The same thing will happen. Port number 80 will be mapped to 30,007. Okay, then load balancer will be created. So the next time, instead of sending the request directly over here, you will be sending the request to the load balancer. So an extra service that you are adding, same thing will happen. One extra service that you are adding, that is a service will be provided by that particular cloud provider, load balancer. So instead of sending the request directly to this particular IP address and the port number, you will be sending the request to the load balancer. As simple as that. How will you send the request to the load balancer? You will be getting DNS, domain name system and all. So ultimately you will be getting that, send the request over there and the job is done. Let's try this thing in action. ls clear. What I want to do, it's better, I want to create load balancers. Okay, great. Do I have the command for that? Just a minute. So services we have created. Have I left anything or some? This is the thing that I have left inside the services. I'm gonna be talking about this. Let me copy it and have it here. Restart the cluster with a few extra ports. Expose the create cluster. Create cluster config.ml and kinda reapply the deployment and the services. Visit this localhost. Okay, what am I gonna be doing? This is the extra thing because the last time what I did. Last time I actually, when it comes to services, th2 how to expose cluster on local machine. Just like this. This is gonna be the question here, and the answer is this. Again, I will be doing it later on, not today. Like you have to just simply, whenever you are creating the cluster, at that time you have to specify that okay, the cluster that I'm creating and merely the control plane that will be exposed on port 3000 on the host machine, and that's it, as simple as that. So on the container, because control plane will have the 3000 port mapped already because of the node port, and once you have created node port or the local balancer, load balancer, so you will already get 30,007 port on each node, and then you will be just simply mapping it to the host machine. This is pretty simple, right? I will do it in action and then you will be able to understand. And again, this is the job of the future. So once I'm done with all these things, then I'm gonna be focusing on this. Coming back to this one, hope didn't miss anything. Services in Kubernetes. Services, we have already talked about this. Load balancer service in Kubernetes. A load balancer service type is a way to expose a service to the external clients. When you create a service of type load balancer, Kubernetes will automatically provision an external load balancer from cloud provider, AWS, Google Cloud, Azure, etc. to route traffic to your Kubernetes. That is right, and we can do that. And this is the command for that. It's pretty simple. It is just like a node router, node port only. So let me just show this thing to you. So paste it here. Load balancer. The name of this can be anything. Let's name it service. This is not the one, sorry, I missed it up. Nginx add deployment. Once this is done, service lb. So let me create another file. The name can be anything, up to you. Whatever you wanna name that, you can name that. And that's gonna be, suppose we are gonna create a service, a load balancer.ml, just like this. You can name it whatever you feel like. Okay, we are not gonna be. Don't worry about that much. And then if you want to apply, you can just directly apply. So /code. How you are gonna be applying? Pretty simple. kubectl and apply f and service dot lb.ml, just like this. Okay, let's talk about this thing, exactly what am I doing here. So this time I have already created this ls. I have already created a service called node port service. Now I'm gonna be creating vi load balancer service. I'm gonna be creating .ml, and it is sort of like that only. So let me paste it over here. What it is doing here. Yeah. API version 1. What you want to create? You want to create a service. What is the name of the service? Nginx service. Name it load balancer service. Completely up to you. Selector. What is the selector? On the basis of the which it will be selecting the. Is this right? Just a minute. Yeah, I thought we specify label over here as well, but we don't really specify the label. Got it. So on the basis of this label, selector will be just simply selecting the service will be selecting the ports. What is the protocol? Protocol is TCP. Port number is 80. Target port. What is the name? What is the target port? Target port is 80. Have a look over here. Port of what? port of, what is the port here? Port 80. Port 80 means the port of this load balancer that is getting created. What is the target port? Target port is means the target port of the container, the target machine that you are targeting actually. So the port of this container I'm talking about, this is running on port 80, that is okay, got it. How about the node port? I haven't specified node port here. Earlier when I talked about this, so we had specified the node port here, right? So you are getting the request here to the load balancer, got it. You have even specified the port number. Where is this node port? You are not specifying that 3007 is gonna be the node port. This node port is automatically selected by the load balancer. So you don't have to specify that you want 3007 or something. Load balancer will get the job done. Load balancer will get any random node port between the range, within the range, so that it works, and it will get the node port. So it will definitely, it does the same thing. It assigns, does the port mapping thing done between the container and your node. But as for this node port, when you created this node port service, you had to specify it on your own. But when you are creating load balancer will get this job done. Interesting. So this much is done. So type is the load balancer. I mean, it's pretty simple stuff, right? Pretty understandable. Let me just save it. And once I've done this much, what will I be doing? Kubectl ultimately k apply. File name is gonna be what? File name is gonna be load balancer service.ml. Let me create this service. This service has been created. Okay, amazing. As this service has been created, so if I get KSVS services, so now I have two services here. No. Something is wrong. 3007. I have this load balancer right now. Where is my node port? Configured. Both of them had the same name or what? Nginx service like very. Okay, never mind. Sorry. The thing is that they had the same names, Nginx service, and because of that thing it got. Earlier I had node port over here. Over here, load balancer, the type was node port. Now the type is load balancer. It just got configured. So what I want to do? I still want to have my. Let me do one thing. Nginx service. So vi and node port. Let me go here. Let me change the name so that it doesn't get configured. Rather, I get a new service here. It will work, but because of load balancer, I lost my node port that I had. That simply means once I lost my node port, that's if I go to this, reload the page. Why is this working? Node port is gone, or probably not. Got it. Problem is simple. The thing is simple. First of all, let me change the name. So name Nginx service, Nginx service node, or let me have this node service. The name doesn't actually matter. Save it here. Done. And this thing is done. And apart from this particular thing, the load balancer that you had, right? So vi load balancer. I will tell you exactly why am I doing it. Tring load balancer service. The thing is that earlier both of them had the same name. So as soon as I applied my load balancer, it configured the same service. So Nginx service that I had earlier, it configured that, it overwrote that. So Nginx service was the same, the type got changed, and what is this thing called? Port mapping remained the same. Because mostly what happens, load balancer creates assigns a new port automatically, but here it did not happen, mainly because I just configured that. So let me delete this Nginx service. So k delete svs. I want to delete Nginx service. And as this service got deleted, this time if you try to access what? If you try to access first of all let it get deleted, bro. It's taking time. Usually things take time, don't worry. But once it gets deleted, so if you try to access something on this port again, you will not be getting the result because the service got deleted. That simply means port mapping is not happening. Reload the page and here you are. As simple as that. Let me create the port mapping for node port. So k apply, file name is node port, run it, and done. Service got created. That simply means right now, if you make a request again, reload the page, here you are getting the result. Keep reloading it. Not one more time. I'm not getting my I'm not getting HTTPD result, but I should definitely be getting that. Let me copy, let me paste, let me enter, let me refresh. How long will it take to just simply forward the request? It's not forwarding for okay, forward it, bro. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. It will not happen. Okay, let me copy it from here and let me go to Chrome. Let me paste it here. Here it works. We copied the same, right? Sometimes things get cached, then we keep getting the same result. 1 2 and then I'm started getting Nginx. So initially I got HTTPS result and then I'm getting Nginx again. But okay, it happens. No worries regarding that. But ultimately we got the result. What else? Okay, what is the next thing that we have to do? We have this much happening. That's amazing. Right now I want to create one more node. Get SVC. If you check out the services right now. So we have one service that is node service, node port, this cat and node port. The name is node service. I didn't really change this really. VI and node port service. Bro, I'll change this. I think nodes. Okay, that's right actually. I thought I didn't change this. The name is node service right now. That's great. Clear it. K get SVC. Yeah. Okay. What is up, bro? I think my terminal is hanging. Close this. K get SVC. So these are the this is the service that I have. I'm gonna be creating one more. K apply F load balancer service. Wait for a while. K get. I created two load balancers. Never mind. K get and SVS. So right now I have this. A load balancer service I have. Node service I have. Load balancer service. Inside this, what am I doing? Inside, this is the URL, external IP, I think, that you got because load balancer provides it. Here the important thing is here that the port number 80 is mapped to port number 31657. How did the load balancer get this? It just simply assigns it by itself, and here in node port you assigned it on your own, right? So ultimately if you still go to this particular URL 3007, it will work, and here you are getting the result from the HTTPS. So this is how it just keeps going on. The important thing, if you actually come to the EC2 machine, if you click on here, if you scroll down, there is something called load balancers. Click on this. Here you have got this new load balancer that has been created. So this is the load balancer that has been created. There is no name as such, bro. Yeah, there is no name. Let me click on this. See if I can find something from here. It is simply saying that yeah, this is the same one, 31657. This is the same load balancer that got created. So as soon as we created this load balancer over here, you will be able to see the load balancer here. You can even get the DNS name. This is the DNS name. Isn't it the same as this one? Isn't it the DNS name that this what can I say, this load balancer service is providing me? If I copy this and if I go here, if I paste it, what should happen? There should be M at the end. What should happen? First of all, something should happen or not. I will have let me run it. What should happen? I should get the result. Will I get the result? Yes, I got the result. I did not even specify what? I did not even specify that I have to go to port 31,657. I think this was the one, right? The load balancer is doing the job of mapping the stuff and all. And at the end of the day, it is providing me what? It is providing me a simple DNS name. If you keep scrolling, if you keep refreshing this, you will keep getting the result. Why is this happening? As soon as you created your load balancer gave you this DNS. It is saying that don't worry about anything. I have mapped port 80 to port 331,657 on your node. Now whenever you are gonna be sending a request to this, that is equivalent to sending a request to on port 31657 on that particular IP. Send the request to this particular DNS. That simply means you are sending the request to the IP address of the node plus this port. So that's equivalent to that. So ultimately this load balancer gives me kind of a DNS. So I have to just simply, this is the external what is it called? External अरे भाई नाम तो आजा. External load balancer way to expose. This is a way to expose this service to the external clients, right? So it gives me this to just simply expose this to the other people, so that other people can come to this one and they can just simply make a request to this. Now they don't have to enter this port number, they don't have to enter the IP, they have to just enter this, and you will be saying it is even more complex. IP and port was simple. You are giving me this particular URL. It is even more complex than that. We will fix it, don't worry about it. But ultimately, this is how it works. And if you actually come here on AWS and know more about it, we have network mapping over here. If you click on network mapping and not network, click on listeners over here, and it is just simply saying that it is listening on what? The instance that I have, the instance protocol is what? The instance protocol is 31657, okay, and the instance protocol, ultimately the instance that is running, and TCP protocol of this particular load balancer is 80. So on whenever I send a request to this what DNS name, this is the DNS name that was even mentioned on the terminal. So whenever I send a request to this DNS name, the request actually comes to the load balancer on port 80, because by default when you make HTTP request, the request goes to port 80 only. So you got the request over here. Then what will happen? This request will be forwarded to what? This request will be forwarded to instance protocol 31657. It already knows what is the IP of the instance. Instance in the sense, where is that one? This particular node. So load balancer already knows what is the IP, what is the port, what is the IP. It will just simply forward the request and that's done. Okay, so I hope it does make sense. Coming back to this one, what will I be doing here? And no, not here. Load balancer. If you click on manage listeners, so what is happening here? So it is just simply saying that TCP request will be coming on port 80, TCP request will be forwarded to 31657 port, that means port of that particular node, and that is done. You can add more listeners over here. What other listener do I want? Interesting stuff. I want that what I want. I want that I already have this, cancel. I already have this DNS, okay, right? Somehow what I will do, I will go to my Hostinger account. Let me go to my Hostinger account, hostinger.com account, okay. And what I want now, I want to create a domain name. Great, let me do that. This is the coding the code.site, and let me click on DNS and name servers. Let me select CC name from here, and that name is gonna be what? That name is gonna be suppose cube dot just cube. So cube should be the subdomain. So this is the subdomain, and this subdomain should be referencing to what? Because look, adding this like copying and pasting is easy. Like you can copy it, you can paste it here, you will get the result. But who will keep typing this to get the result? No one will do that, right? Why it is taking time? Okay, now I got the result. It was taking time. Okay, so who will type this long URL? So what do you want? That I'm going to create I'm gonna do one thing on my hostinger. What will I do? I'm just gonna be creating a domain name for this. I'm gonna be assigning a domain name. So I'm gonna be just simply saying that cube or Kubernetes, this particular subdomain will be referencing to this particular target. As simple as that. The target I got from the it will be referencing to this. No, this is wrong. Sorry, I have to copy it from AWS itself. AWS. Here it is. So it will be referencing to this. Okay, let me go back to my target. Let me paste it here. Once I have done this much, let me add the record. Okay, so what happened? I have this Kubernetes subdomain referencing to this particular DNS that was given by what? That was given by AWS itself. Now, if instead of writing this much, what will I type? I will just simply type this Kubernetes. My domain is coding the code dot site. If I just simply run this much, what will happen? I will still get the result. I know that. Here we are. We have even added the domain. We will even make a secure secure. Just wait for a while. Okay, so we have done this much. We got the domain name. We created a subdomain. We reference that subdomain to that particular domain name. Now if I write Kubernetes coding the code dot site, I'm getting this. There is only one problem. What is the problem? That whenever I send the request, it is not secure. That simply means if I copy it from here and if I paste it suppose here, the request goes to HTTP. How about HTTPS? Why don't you ask certificates? I said great, let's do that. So for that thing, we will have to create certificates so that we can add it. Okay, that's great. Let's create the certificate. Let's come back here. Let me click on listeners. Let me click on manage listeners. And this time what will I do? I'm gonna be adding one more listener added. What I want to get the request at HTTPS. The request will be coming now on port 403. The request will be forwarded to port HTTP and the port is gonna be this. Simple. What I'm saying, I want to get the request on port whenever I'm writing coding the code Kubernetes coding the code dot site. So I want the result on, I don't want the result on port 43 now. I want to get the result on port HTTPS. Great. That particular request that I get on port 443, it will be forwarded to this particular HTTP and this 31 this particular port. If I say TCP, it's gonna be problematic. It will not be problematic. Wow. Interesting. So I can even have this TCP over here because Kubernetes supports that. So I'm gonna be going with this. But there is one problem. You cannot do it directly. ELB security policy. Okay, that's great. It choose a certificate. It is just simply saying that if you want to do it, do that. You will be sending the request using HTTPS, but you need a certificate. Click on edit. Here I already have one certificate, and the way I created this certificate, that is now what to call it, wildcard.coding the code dot site. That simply means I can have anything before dot and that would be working. So I already have this I already have the certificate. Now the question comes, if you don't have, how will you create it? Click on request a new ACM certificate. You did that. Okay. Then what will you do? Click on request. I already have one. Click on request. Click on next. Add the name. Suppose name can be everything wildcard.coding the code dot site. And now I am adding wildcard over here so that I don't have to create the certificate for each and every request. By the way, this even can be Kubernetes, but this will only be valid for Kubernetes. But if I'm adding wildcard over here, that means for all. So let me add this Kubernetes here. So Kubernetes coding the code dot site. It's completely up to you. I already have the certificate. I can directly continue from there. But for you I'm creating it. So Kubernetes this, and don't do anything. Let's simply click on request. So what will I get? Wait for a while. I gotta wait for a while, that is for sure. Okay, so it is just simply saying that pending request. It is saying that copy this CNAME from here, go to Hostinger. Okay, now go to Hostinger. Here I am on Hostinger. It is saying that select a CNAME, selected CNAME. What is the next thing that it is saying? It is saying copy this CNAME, copy this CNAME, go to Hostinger, paste this name over here, pasted, then copy this CNAME value, copied, pasted over here, and add it over here. Once you have added, now AWS will verify whether you have the right domain or not, and once that is verified, this pending validation will be verified. Reload the page. It is still pending. Let's wait for a while. Still pending. Let's again wait for a while, but it should be done quite soon. How long will it be pending? Even my heart is increasing now, like beating faster, like whether it will be verified or not. How long will it take, man? It doesn't take this much time usually. Usually it doesn't take this much time, seriously. Don't know, for some reason it is taking this much time right now, but hopefully it's gonna be verified. It's been issued. Okay, so that simply means it has been issued. Now what I have to do, I have to come back here again, and this time if you select this, I'm getting two ones. This was already created, wildcard.codingthecode.site, and this one kubernetes.codingthecode.site I create right now. I'm gonna be selecting this one. You can select any. If you are selecting this one, it is simply saying that wildcard means in the place of wildcard you can keep anything. Kubernetes, in the sense this is just gonna be for one Kubernetes. Okay, that's great. Click on save changes. Save the changes. You have even added the policy ACM edit. What is the problem? From ACM, yeah, save changes. And once this is done, then don't do anything. Let's simply click on save changes. So now what? Listener protocol and listen protocol must match. Okay, let's keep it HTTP. I thought it would work 98, but sorry, TCP, but that doesn't work. Let me click on save changes. It got saved. Now, if I'm sending a request to what? If I'm sending a request to https codingthecode.site, let me send https://kubernetes.codingthecode.site. Welcome back to the world of SSL certificates. Well, I haven't got the response yet. We'll be getting the response very soon, but let's see how long it takes. There's gonna be a problem. What is the problem? The problem is that I haven't allowed in the security group load balancer, in the security group of the load balancer. So let me go to the security group of the load balancer, and don't worry, things are fine. So if I come to this load balancer here, and if I go to the security group, if you check this here, let's click on this, add this. Most of the time if you are not getting the result, that simply means security group is blocking the request. So if you actually check, have a look over here. So we are only allowing port 80. We are not allowing port 443. So let's click on allow. We want to allow what? We want to allow, and most of the time in DigitalOcean it gets done automatically. In AWS you have to configure the things. This is done. Port from anywhere. Let's click on save changes. And that's it. Congratulations. Now if you come here, the URL is the same, and here you are getting the result. Congratulations. Now you are typing what? https://kubernetes.codingthecode.site, and yeah, it works. And then slowly you should be getting come on, you should also be getting Nginx. So ultimately we have two nodes are running. One is running HTTPD, another one is running Nginx, and because there is something called load balancing that happens automatically. So whenever I am sending the request, so by the way, I'm sending the request to what? I'm sending the request to this load balancer. So right now what is the flow? The request actually comes to this particular load balancer, and that too now on port not 80, port on 443. The request comes here, and once the request comes here, load balancer already knows where to forward. Load balancer knows the IP of this and port of this, IP of this and port of this. It automatically sends the request here. The request will be handled by this or this depending on the load balancing stuff, and this is how the things get done. Let me delete this. Let me come back here. If you go to HTTP it will automatically be converted to HTTPS. Well, not converted. I'll have to remove this. HTTP should not work. That is allowed, so you are able to get the request. I will even remove this. So you will not be able to send the request to HTTP only. By the way, coming back to this, reload it. Not this here. Come on, reload this. Here I'm even getting the nginx, so it just keeps changing, keep load balancing. Okay, one last thing, that bro, that's okay, you are using HTTPS, but if you just remove this yes from here, you are still able to send the request. Yeah, and you are able to get the request. That's isn't that, well, you are not. But if I just simply remove this, if I copy this, if I enter this, well, right now I'm not able to enter that. Okay, here, yeah, so you are still able to send the request. So why are you able to send the request? And the answer is that in my load balancer, in my load balancer, if I go to edit, not this, yeah, in my load balancer, if I go to listeners, if I go to manager listener, I'm still listening the request on KCP, right? So let me just remove it from here. Let me save it. Simple. Now if you try to make a request to this, not this, to this HTTP, to this, yeah, reload the page, bam. Okay, so this is done. How about making a request to HTTPS? You will get the result. Okay, so this is how it simply works. I hope it does make sense. And this time let me remove everything. Hopefully I have explained everything in the best way possible. And we have talked about Kubernetes, load balancing stuff and all, kubectl, apply, f deployment, and service lb. We can even delete the stuff and all. Even I will show you how to just stop everything, because if that's running, your AWS account will consume a lot of, drain a lot of money of yours. Kubectl apply, let's simply click on next. Then a series of events, create your cluster. Okay, let's not worry about it. We will be talking about the remaining things the another day. So we have done this much. What is the next thing that we have to do? As simple as that. Right now we have to stop everything. Stopping everything in the sense, first of all, EKS, CTL. First of all, let's check out the things. K get pods. These are the pods that we have. Let me delete all the pods. K delete pods. All of them are gonna be deleted. K, wait for a while. It will be done. Oof, it's been quite great, yeah. I don't even know how long has it been. It was simple, even since it has been clear. I'll only leave when everything's done, and right now everything's done. Congratulations. By the way, it's taking a lot of time, because the thing is that things are running on the AKS machine, so of course it will take some time. Only one thing is remaining, and what is that? Let me do that here right now. That is, should I do that? Yeah, why not? It's Chaitais. How long has it been? It's been 3 hours 47 minutes. Koi na, there is one more thing, that right now we have got everything done, but there is one thing. How about if I don't have a Kubernetes machine? How about if I don't have a AWS account, I don't have a DigitalOcean? How will I check that this service stuff is actually working? Okay, in that case, there is one more way. You can directly check the things on your local machine. Yeah. So, and then later in the future you can get the Kubernetes machines and all, but definitely try to just manage it somehow. It has been stopped. Kget and kget what bhai, kget pods. I don't have any pods. Kget ReplicaSets. Kget deployment. Done. Kget services. Stop these services, otherwise they will consume your money. They will empty your bank account. Delete. If you are not running that, then of course you have to SVC and load balancer. Delete that. I not found, not a load balancer.ml, bro. Load balancer service. Delete that. Service load balancer is not found. Load balancer, the spelling is wrong. balancer, run it. Deleted. I could have done one more thing, like delete the cluster directly. It will remove everything, but I don't think so. It will remove everything. First of all, delete everything like manually would be better. By the way, it will take some time to just delete the service as well. You can even check the things here whether it's actually working the way you want it or not. So coming back to this one, cluster I have. This cluster is still running. If you just simply refresh this, so we still have this particular cluster here. And as for the services, how will you get the services? So you have to just simply search something like VPS, virtual, something, whatever the full form is. If you come here, and inside this VPS, you will be checking like your VPCs, how many VPCs you have. VPCs in the sense the clusters that you have, and then your subnets. These are the subnets that are being used. Route tables, and where are the service networks latency. I should have them here, yeah. Service networks, I think this is the one. Services, I should be having services here. Can you see the services somewhere? Services. Getting started, security groups. Subnets you don't have services here. I'm forgetting them exactly where that I can find it. Where can I get the services from? Never mind, but somewhere or the other you definitely get the services. Right now what we are doing, we are deleting it from here. So that service has been deleted. K delete SVC, and I'm gonna be deleting node service as well. Delete that service too. So then clear everything. There's a lot of things here. ls, once that service is deleted, so what else? K get nodes. We have these nodes running right now. And apart from this particular thing, do you have anything? No. And now it's time to delete. So how will you delete the cluster? The EKS, like AWS cluster. Either there are two ways. Even you could have, I didn't show this. You can create on this create cluster, and you can specify everything like this, the name of the cluster, and everything else. You can check the things out exactly how you can create the cluster. Cluster can directly be created from here too. What is the benefit of creating the cluster from the command line side? You have to write your configuration only once, then you just apply that, your cluster will be created. And here whenever you have to create a cluster, click on this button, select this, keep going through this. So it is gonna be a long process. You will have to configure many things. And on the other side, if you are using a command like ML configuration, so just you have to write things one time and the job is done forever. Okay, you can do it from here. And similarly, you can delete this cluster from here as well. But what we are gonna be doing, we are gonna be deleting it from here. So EKS, again, if you wanna create that cluster or delete the cluster over here, only on Amazon, we use EKSCTL. EKSCTL delete cluster. Name is what? What is the name of the cluster? EKS cluster. EKS cluster. Should we delete that? Why not? So it has started deleting your cluster. It will delete most of the things, and like load balancer, you will have to delete on your own. It will automatically delete the EC2 machine. Okay, so I will show you. It will take some time to delete that as well. So it's not gonna be quite quick stuff. It will take some time and all. So okay, let it take time. And apart from that particular thing, can't really do anything until unless it has deleted. So I'll actually have to wait. And apart from this particular thing, if I go to Hostinger right now, hostinger.com, I have added it for no reason here. That Kubernetes one, that was just for the testing purpose. So let me delete some of the things from here as well. Like one certificate I have. What the hell? Okay, this DNS. So this CNAME that, okay, which one? I forgotten. Okay, it is, I better delete this. Uploads, this is still being used. Learn Hub, this is not being used. And Kubernetes, this is also not being used. And React, this is also not being used. Uploads, okay. And now I don't know which one belongs to Kubernetes here. Okay, this one belongs to Kubernetes. I hope so. Yeah, definitely this one. So let me delete this. Even if I deleted the wrong one, I can create the certificate anytime. That's not really a big problem. Okay, done. So once this particular thing is done, close this, and The remaining things are on the AWS itself, right? So let's come back here, and hopefully this will be waiting for cloud formation stack, EKCTL and all. It will just simply delete all the things and all. So this is it. And apart from this particular thing, series of events, create your cluster. We have created the cluster, and okay, this is for the role. Deploy your pod, um, exposing it to the local device, and that is it. And how do we expose it? We expose it like this. So we follow the same process. When we create the cluster, at that time we have to make sure that whenever you are creating the cluster, so the control plane that you have, that control plane, and so what should happen here? So the port of control plane, ultimately 3007, because whenever you are getting service, so node port service, so this 30,007 30,007 will be created on what node control plane as well. And then once that is done, then you will be just simply attaching that, mapping that to the 30,007 port of the machine, and then the workers are gonna be there. And then what will happen? You will send a request to the control plane. Control plane will be forwarding the request to the local workers, and this is how it just simply gets done. Pretty simple. It's just that I have to just simply show it this thing in action. Otherwise, this is how it just simply goes, bro. Kubernetes, clusters, pods, ReplicaSets, deployment. There is something called Anchor. I don't know, something. There are a few more things that are remaining. So I'm gonna be learning about them. Then of course I'm gonna be talking about them here on YouTube, and hopefully this is done now. This takes a lot of time. At least consider it that it would take around 5 minutes at least. And until then I'll actually have to wait. Or let's do one thing. I'm gonna be catching up tomorrow, and I will exactly show you how you can expose it on your local device, because it is just gonna take time. And if I say here get find get clusters, will I get? Oh, I have my local cluster. I can do it. Why not? I already have my local cluster over here. So get nodes. How can I start my cluster? How to reload a kind cluster or restart kind, because right now my AWS cluster was connected, and because of that thing my local cluster was disconnected and all. So I will have to restart cluster. Restarting kind cluster. No, 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 no. Docker restart kind container. I have that running. How can I fix this? There is a way. I forgot that. I may have to create another container. Let me create one. So ls, I don't have it here. And did you specify the right host or port? So kind delete, and what kind delete cluster name is gonna be local cluster. Let's simply delete this. So local cluster is deleted. And kind get clusters. I don't have any clusters. And then ls, I have this clusters.ml, cat clusters.ml. What does this do? It just simply creates it. Right now we are going to be making some changes inside this. What are going to be those changes? Let me come here. Let me go to my nodes, services. When I'm creating the cluster, I'll make sure that it is actually exposing the control plane to the host port of 3007. Then I'm going to be creating the service. So let me interesting. Vi clusters. There is a shortcut. You have to type gg, small gg, then shift vg. First of all, gg 2 times in small letters, and then shift capital G, capital V, vg again, capital V, capital G, and then say control shift V. Selected all and replaced all. By the way, what I'm gonna be doing here, simple extra port mapping. So this is like the control. Earlier you were doing this much. This is the extra thing that I'm adding. This is the extra port mappings, and it is just simply saying that container port 3007, that means this control panels once, and it should be mapped to the host port. That simply it's just like this. Let me save it. I will exactly show you how it works and all. So this is done, and then kind create cluster. What is the configuration? Configuration is clusters.ml. The name should be local cluster. Let's do it. It's gonna be created right now. And apart from this particular thing, so what will happen here? So as soon as I created this cluster, so this is my Linux machine, right? So this is my Linux machine. As soon as I created this cluster, so I did one thing, that bro, your port 3007, ultimately master's port 30,007 actually. So master's port 30,007 will be exposed to my local machine, if I'm not wrong. So this is how it works. So it will be exposed to my host machine 30,007. It's gonna be exposed here. So this thing is going to be exposed. So what will happen? I will send a request to this localhost 3000. It will be sent to the master. Master will be responsible for sending sending a request to the edge, and this is how it's gonna be done. Overall, this is what I think it should usually happen, and the remaining things are gonna be the same. Pretty simple. It has been created. Get pods, get nodes. Do I have nodes? Yeah, I do have nodes. I have control plane running. I have 2 workers running. What is the next thing? The next thing is pretty simple. Create the cluster. So cat deployment, I already have deployment.ml. So if I see, so what am I doing here? Inside this, you are just simply creating a container nginx, and this is how you are going ahead with the things. So let's simply apply it. So k apply f and deployment. This is the benefit of writing the configuration once, and you can just use it again and again. Apply it. So ultimately deployment is created. K get a deployment. So yeah, deployment has been created, but you needed 3 replicas, but none of them are ready yet. So let's wait for a while. Okay, 1 by 3, 2 by 3, 3 by not 3 by 3, 3 by 3. So first of all, 1 of them got ready, then 2 of them got ready, then 3 of them got ready. And if you check get deployment is done, replica sets. So this is the replica set that you want. So just some gibberish, some characters got added after the cluster's name, and then deployment name got ready. K get pods, and if you check this thing out, so even just after that few more things got added, that became the name of the pod. If you just check the log of the pods, so k logs, k in the sense kubectl, you can write kubectl properly over here. Kubectl get not get kubectl logs, and okay, that even machine has been stopped finally. And kubectl logs, and what else? The name of any pod that I have, run it here. So these are the logs, as simple as that. And what am I gonna be doing here? This is already running. All the pods are already running. And let me create a service. ls which service? I'm gonna be creating node port service. Let me cat node port service here. Cat node port service. So what am I doing here? A node port service nginx. The target node port is 3007. That simply means it should be exposed on 3007. Let's see. So k apply f node port service, k get svc services. So the service is here, node port service. It has been created. What is happening here? What should happen here? Let's forget about everything else. I have exposed nginx is running one of the pods, and I have exposed it to port 30,007 using node port. Now, and it's been done on all of them, and they've been even all of them, yeah. And at the end of the day, that I will be even I have exposed the 30,007 to the 30,007 port of the master to the local machine. So I'm gonna be sending a request to this. This will be forwarded to the master. Master will be forwarding it to this as well as this, because again master knows where to forward the request. Hopefully this is what should happen. Let's see. I'm not sure about this thing. Okay, so let's see how it's gonna be going on. So localhost 30,007. Welcome back. You are getting the result on your local machine. Did you get that? So it's not like right now you are getting the result on your local machine just because of this configuration. because by default what happens, this is the overall structure. You have your Linux machine, okay, this gray color is your Linux machine. Inside Linux machine you created your Kubernetes cluster. Exposing this to the main Linux machine, host machine, is quite complex, but services makes it really simple. Services says that okay, there is node port service. What will this do? You have to just specify the node for the node port for the node. So the container that is running, the service that is running inside the container, that the port will be mapped to the node's port, whatever you specify over here. Great. Same thing will be done on this, and same thing will be done on this. Why? Because they have the same label, so they are kind of same set of ports. Okay. And then while creating the cluster, what you did while creating the cluster, you said that inside my master, probably inside my master I have 30,007 port, and let's simply map it to the port of the machine, so host machine. So it is mapped like this. Now whenever you are sending the request over here, it is forwarded to this and this, and this is how this simply goes on. Quite simple. And this thing you did not need to do when you were deploying it when you were using Kubernetes clusters of AWS or DigitalOcean, because you could have gotten their IP address directly, or the second thing is that you could have used load balancer. So you send the request to the load balancer automatically sends the request to the master, probably master, and then it is just balanced to all these things. So this is how it just simply goes. Overall, if you actually have a look, so cloud provider API, whatever API you get, so from the cloud provider what happens, you send a request to the cloud control manager, the request actually goes to the API. From the API, so ultimately the request comes to the control plane worker node, master node, and then from the master node the request will be going to the some specific nodes and all. So ultimately this is the diagram that I actually got online, and that is it everybody. We've done it. We have actually done it. We are able to get the result. And now what will I be doing? K get pods, and let me do one thing. K delete, I'm gonna delete the deployment. K get all, and this is the name of the deployment. Here I will be getting everything. So K delete, the name deleted. K get pods, don't have any. K get services, yeah, I have one service. K delete SVC node service, done. K get ReplicaSets, no. K get nodes, yes I have. K not K, kind delete cluster and local cluster. I'm gonna be deleting the clusters as well. K get nodes, don't have any nodes. That's kind get clusters, don't have any clusters as well. Exit the EKS elastic Kubernetes cluster, that has also been removed. ls K get pods. I mean ultimately you will be getting nothing here. Yeah, so ultimately right now everything is done, and apart from this particular thing, if you not here, if you actually check the Docker processes, Docker process status, nothing is running. Docker process status stopped, nothing is running. Exit from here as well. And if you go to your AWS account right now, if you refresh the page, the cluster has been deleted. Okay, this thing is done, and your account is not a member of an organization. I got scared seriously. As soon as I got this error here, I thought something went wrong and my account is, I'm about to lose my account. It was just like that. Okay, never mind. I could have created another one as well. And then services and your VPC. If you have a look at the VPC, let me refresh this. So EKCTL, my cluster VPC. I have to know more about it. Exactly why do I have them? Let me just simply ask to the ChatGPT. This is how I learned. I mean, you get stuck and then you take the help of AI and then you clear all those concepts. The question is, even if I have stopped, the EKS machine or cluster, why am I getting the here? This is completely normal. This is nothing is wrong. Short answer: even if you stop and delete your EKS cluster, the VPS does not get deleted automatically. Why? You still see VPS when you created your cluster using EKCTL. It did this: created VPS, created subnets, created security groups, created EKS cluster inside that VPS. EKS cluster inside that VPS. What is the full form of VPS? VPS full form in EKS. Virtual private server. Okay, so inside this only it gets created. Your job. Okay, so now what happened? You said I stopped EKS cluster. That only affects worker nodes, EC2 instances, Kubernetes control plane if it is deleted, but AWS does not delete VPS, subnets, routes, tablets, internet gateways. Think like VPS is a house and EKS clusters furniture inside the furniture inside the house. Okay, that's fine. So if you remove furniture, the house still exists. And the screenshot you have this created another default VPS. This stay until manually delete. Important billing. Even if cluster is deleted, VPS is free. Oh, VPS is free. If free, we don't care. But things inside VPS may cost, net gateway, elastic, and all. So always check this. Should you delete VPS? Yes. If you don't need it, blah blah, delete it. Best recommended way: if you used EKCTL, delete everything. So EKCTL delete cluster, name this. This removes cluster nodes most resources, but sometimes VPS stays. EKS does not auto delete VPS. VPS is a separate AWS resource. If you want, I can help us every delete. I'm gonna be deleting that. At least now, right now. Later it's select delete VPS. Unable to delete. This VPS cannot be deleted until you complete the following actions. So the VPS contains more in use in network interfaces, net gateways. Okay, so I have to delete them, cancel. So network gateways, net gateways. So this is the net gateway that I have. Select. I can delete only one at a time. Delete net gateway. One is already getting deleted. Let me delete this as well. Delete. So this is also going to be deleted. And apart from this particular thing, what else it needed? If I want to delete this, so it is just simply saying that net gateways is a network interfaces. Network subnets, routes, internet gateways. This peer connection network. Network, bro, where is that? Network is three subnets. Do I need to delete them? Fail to delete. The network is does not exist. Interesting. Routes, net gateways. That's we've deleted already, and internet gateways. Delete from VC. The internet gateway. Cannot be detached as a 3. There are some mapped public addresses. Please delete the following net gateways. So net gateway hasn't been deleted yet. EKS this. So that's the thing causing the issue. Let's come back here. I'm gonna be fixing this. Let's see. So this is what I have deleted, right? Action. Bro, I cannot delete it. Okay, whether it gets deleted or not, that doesn't really matter. I think one you have by default, if I'm not wrong. Elastic iPage. Disable. Cannot disable. The following address will not be disabled for the transfer since they are not enabled for the transfer. Cancel your VPCs. Yeah, though. I mean, today it's not gonna be happening. I will not be able to delete this. Delete VPC. It is saying that instances. Really? Do I have instances here? Oh, is this being used with this? They are already terminated, and probably I have this. Okay, never mind. Later I will be removing everything from here. As for this Google Meet clone, let me terminate this as well. Google Meet clone, terminate, delete, terminate. This is gonna be terminated. And apart from this particular thing, I have this load balancer over here. I'm gonna, oh wait, load balancer has been deleted automatically. Amazing. Auto scaling group, we don't have any. Target groups, we don't have any. I didn't really create it. Elastic security groups, we have actually many. Yeah, kind of many security groups are here. Deletable will be deleted, and the ones which are important, they will not be deleted. As simple as that. At least one thing is done. The next thing is that I have to work on that Google Meet project, and let's see, I will be back after half an hour and then work on that too. Until then, I think this should be it. I think we have gone through each and everything here, and nothing is remaining. Instances are also terminated. That simply means coming back to this one. Network interfaces. Let's check this thing out, what it is actually. So when it comes to this network interface, so this is inside what? Network interface is inside this. Amazing job, lovely, loved it. At least I'm able to find this, but there is no network interface as such. That simply means if I come back here and if I try to delete this, interesting, now I'm gonna be able to delete. So delete default VPC. The good thing is that it just simply tells you that this is what you have to stop, then only you can delete it. So you don't need to search that manually. That's a good thing. Let's click on this, click on the action, delete VPC, and I can do the same over here. Delete, delete. Okay, everything's gone from here. Refresh this. Yep, seems to be gone. And then subnets. Do we have any subnet? Not really. Routes, do we have? Yep. Delete route table. What is the problem? Route table have associated associations and cannot be deleted. Associations with these, but I have already removed them. Refresh this. Route tables are the main routes tables for a VPC cannot be deleted. Okay, let's cancel it. Just a sec. I should be at least able to delete this. Okay, turns out I cannot delete this. Why? Okay, if I cannot delete this, then I should be able to. Okay, I should be able to. Route tables have associations and cannot be deleted. The following routes tables can't contain one or more associated subnets or edges. Associations cannot be deleted until those associated subnets or edge associations are removed. Subnets have already been removed. Do I have any? No. And elastic IPH net. Okay, remaining things I will figure out tomorrow. I mean later. Overall, we have done the things. Interesting, everybody. Let's see how many things I have on my main page. We have gone through AC2, we have gone through a VPS certificate manager. Okay, how many do I have here? One of them I need to delete. So I have this one needs to be deleted. So delete. Okay, so this thing is also done. Let me reload this. So this thing is done. Coming back to the home page again, and VPS Elastic Kubernetes service. I am okay. No need to change anything. Cloud formation, Elastic container service. Even we talked about this Elastic container service. How you just manage the containers, like upscale, downscale the containers on AWS directly, and S3, CloudFront, AWS. Okay, these are the things that I have already explored on AWS, and I have the knowledge of these things on AWS. Such a good thing. By the way, now I'm gonna be catching up back after half an hour, and we are gonna be working on that Google Meet clone project. That is not like clone now anymore. That is actually a build project, and that is gonna be having even more features than Google Meet itself. But having said that, we are gonna be adding more features on that. The overall project is already ready. Now it's gonna be time to make it even better, add even more functionalities, make it look even better. I mean, whatever. I hope you got the idea. So I'm gonna be catching up after half an hour. Until then, take care. Bye bye and see you. It was great meeting you guys and great learning together. Bye bye. See you.